So a very good morning to all of you. So I hope you are enjoying the conference and you had 2 great days. Yesterday night, I think we had a wonderful banquet along with a wonderful music program. So I hope you enjoyed it. So we are now back on the third day of the conference and we start with the conference type presentation. So unfortunately, due to some problems, some personal problems, as well as due to flight cancellations, none of the authors from the first two papers would make it to the venue. So we have online presentations for them. The first paper is NDA Gen Uno Semantically Inclined Medical Document Annotation for Genitourinary and Urological Pathology. And it will be presented online by Mohammad Salman SA. So, Mohammad, can you hear me?
Yes, sir. Hello, sir. Good morning, sir.
Good morning. So, you can start the presentation. You can share your screen and start the
Yes, sir.
presentation.
Yes, sir. Sure. Hello, sir.
Yeah, we can hear you, but we cannot see the
Yes.
screen.
Sir, actually, from your side, someone is presenting the screen, so the meeting is not allowing me to share my screen.
Okay. Just a minute. Now,
Yes, sir.
check. Yes, so make it full screen.
Yes, sir. I hope my screen is visible.
Yeah, so you have 10 minutes to present. So please start.
Yes, sir. So, good morning, everyone. I'm Mohammed Salman from National Institute of Technology, Tiruchirappalli. So, today I will be presenting our work titled MDA Gen Euro at the FIRE Conference 2025. So, basically, our work focuses on building a semantically driven medical document annotation framework, which is specifically designed for the genitourinary and urological pathology domain. So, a little background before the problem statement, I would like to give a brief. So, in the recent years, what we have seen and is that there has been an exponential growth in the medical documents. So, upon the literature survey, what we have noticed is that without proper annotation, these documents remain difficult to search or recommend or reuse. And with the development of the Web 3.0 environment, the focus has shifted from keyword burst based retrieval to semantic understanding, making annotation systems very important in the Web 3.0 ecosystems. And in the same space, I would like to explain our problem statement. What we identified is that whatever the existing annotation methodologies are largely focused on general purpose, or often they most often fail to handle complex medical terminologies. And more importantly, there are no dedicated annotation frameworks tailored for the proposed field, which is the genitourinary pathology, which is both clinically important and it's, I should say, it is very terminologically dense. And now the motivation behind our work. So our motivation basically comes from Sir Tim Berners-Lee's vision, a renowned scientist who is the founder of the World Wide Web, whose vision of Web 3.0 is that where data must be machine understandable and not only semantically inclined. So whatever the medical documents today are poorly integrated to this Web 3.0 ecosystem. And this gap particularly highlights the need for an annotation framework for highly specialized medical domains and like the specialized domains like the proposed one, urology and pathology. And our key contribution is that uh, our work makes several novel contributions, particularly. First of all, we introduce a novel, first in the class domain specific annotation framework for the proposed medical fields for genitourinary pathology. We integrate an LLM-based knowledge generation, semantic statistical reasoning, and particularly a nature-inspired optimization algorithm, which enabled us to achieve state-of-the-art performance, surpassing the baselines for this field. Now, I would like to explain about the architecture we have presented. And what the slide shows is basically our overall architecture of the architecture of our framework, the pipeline first starts from a data-driven term extraction using the term frequency, inverse document frequency, and it gradually moves through semantic enrichment and metadata classification. And this pipeline, which we built for the specialized medical domains, finally produced optimized and high-quality annotations. And first of all, I would like to explain with the TF-IDF. We begin with the term frequency inverse document frequency, which ensures that our framework is particularly data-centric, dataset-centric. Uh, the reason we have used TF-IDF is because it properly filters out noisy terms and highlights informative medical entities that truly represent our dataset. And second one is that we have integrated LLM, particularly the YLLM, which is used to generate captions along with the dataset terms. Now, these terms are validated against a verified medical knowledge stack, ensuring that the domain relevance and uh, there is no deviance from the domain. And next one we have is the semantic reasoning. And as a part of this, we apply, as part of this methodology, I would like to give a brief brief of the this semantic reasoning part. After enriching the term using TF-IDF and integrating LLM and the medical stack, the next challenge is the semantic reasoning. So at this stage, we have a large number of candidate terms, which are the initial terms and the entities. But we should remember that not all of them are equally useful or reliable. And so, because some may be redundant or some may be loosely related. And others may not be truly belong to the proposed field of the genitourinary domain. And in the same space, to address this problem, we introduce semantic filtering using statistical similarity and dispersion measures. And the first one, as presented in the screen, is the use of Morishita's overlap index. So in our framework, we adapt this index to measure how strongly two data sets of two, particularly two medical data sets, overlap across different documents. And the one advantage of this using of this Morishita's index is that it does not get biased when the document size is increased. And now next we apply the index of dispersion. Now index of dispersion is basically the ratio of variance to the mean. And this measures as this index of dispersion helps us understand whether a term is evenly distributed across the dataset or overly concentrated in small number of documents. And in medical annotation systems, we want the terms that represent the entire domain, not just the isolated cases. And after one of these two filters are applied, now we obtain what we call the feasible enriched dataset term for the specialized domains. However, one thing what we found is that the semantic similarity between terms still needs explicitly quantified. So for quantifying purpose, we use the Jaccard similarity, which directly measures the overlap between two sets by comparing their intersection over the union. And finally, together these three measures play very important roles. And the next step is the metadata classification and optimization. The metadata is generated using the OpenKLACE, and we use RNNs to classify this. And as a next step, we apply the nature-inspired optimization algorithm, which is the animal migration algorithm, to derive the optimal annotation set. And here is the displayed is the results of our proposed framework compared to the baseline models in the same field. And our proposed model, MDA GenNeuro, achieves 95.12% precision and a false discovery rate of 0.05, lowest among all. And I would like to conclude by telling that the MDA GenNeuro system, what we have built, is basically a best in class and first in class in this particular domain for urology, combining where we have combined semantic intelligence and generative AI. And as the results display, we have achieved high accuracy, low false positives, and which is a strong framework compliant completely with the Web 3.0 ecosystems. And this framework, what we built, can be also used to extend to other critical medical domains. And thank you from my side. I would like to thank the committee for giving us a chance to present at the FIRE conference. Thank you, one and all.
Thank you very much. I'll so any questions from the audience or participants who are present online? Okay, there are no questions. I have a question. So do you have any examples of queries and responses from your search tool which you can give to us? Anything like that? You have only presented some quantitative results, but are there any qualitative results, some examples? Mohammed, are you there?
Yes, sir. Hello, sir.
Yes, hello. So
Yes, sir.
can you give us any examples of queries and responses from your system?
Sir, at the moment, I am unable to access it because it was part of my author's work, and my role was predominantly focusing on the semantic part, which I elaborated briefly.
Okay, so semantic kind of, I mean, just explain with one of the examples, like what kind of queries were given and what kind of responses were obtained from the system. Anything of that sort, because we have seen a high level descriptions, TF, IDF, and other mechanisms which you discussed. These are common in almost all search engines, right?
Yes,
So,
sir.
anything distinctive here, it is not present in other search engines, anything like that.
Yes, sir. So, like you said, I would like to highlight that the TF-IDF is basically used in most of the frameworks, annotation, and recommendation systems. But what we try to highlight is that we have integrated semantic searches like the Moricitas overlap index, and I try to tell that we have built a semantically inclined framework, not just using basic NLP principles such as the TF-IDF.
Okay.
And
So
as a
the
part of,
over,
yes, sir.
yeah, so it was using the medical vocabulary to improve the overlap of the tokens, right? And that gives semantic age to the system.
Yes, sir. Yes, sir.
Okay, thank you very much once
Oh, sir. Thank
again.
you very much, sir.
We'll move to the next presentation. Are you present? Okay, so Dia, you are present. Can you join? Can you start sharing your screen?
Yes. Hi, good morning. I will try to share my screen.
Yeah, so just let me introduce the title. From from climate from climate headlines to stock rates, a sentiment-aware financial model. So it's by TCS Research Innovation Lab from Kolkata. So yeah, you can go ahead with the presentation. You have 10 minutes.
Hi, good morning. Today I am going to present the our climate finance work. In this work, we try to take on to the climate take on to the climate risk as an information problem. As we can see that as climate change becomes a more pressing problem in today's world, when the newspapers or social media are reporting some climate risk or climate change, the market is also affecting. So we found out that climate change introduces systematic, long-term, and non-diversifiable financial risk, because even though the government bodies are now enforcing many climate rules, these rules are always not observed by the market, and as we see, the more the social media platform or news platform is reporting this, the more the more mm, the the market value of the products are affecting. Traditional hedging methods are not or most ineffective for climate risk, because the climate risks are long term. And so our goal was to check if existing climate finance work in the climate, we can use the fine-grained sentiment analysis or policy signals from the news data. As I said, that our goal is to do this, do the four listed. Uh, This is our data set. We use for the news data, we used Guardian News Repository, and from the Guardian News Repository, we got almost 363K articles from 8 different categories. For the financial data, we used Yahoo Finance, where we have used 10 representative stocks for various categories like energy, renewables, aviation, utilities. And we specifically took the Guardian News Repository because of its strong climate reporting and developer-friendly API. We have also used government sources like EPA, UNFCCC, and IPCC for the climate vocabulary glossary creation. This is the yearly distribution for our crawl news data. As you can see, we got news from various categories: science, technology, environment, education, and business, entertainment, etc. And we found out that climate news come from all these different categories. This is our model architecture. And as we can see, we got the climate signals from the news repository, crawled news repository, and we did the sentiment analysis and took the sentiment score. And we used LLM to extract climate policy related updates from the news data. Sorry, my screen stopped working. Um,
Yeah, can you reshare your screen?
Yeah, actually, so sorry, my screen stopped working just a bit. Please give a moment.
It was visible.
Oh, okay.
After Yes, it's useful.
So I created the climate change vocabulary. I aggregated the glossaries from IPCC, EPA, and UNFCCC, and for the more emerging terms, I extracted the climate change related terms from using Llama 3.370 billion from the newer repositories crawled from EPA USA and EPA Canada. The more I have found some, I have also given some examples of the emerging terms, and this is the word cloud created from the glossary. To create the sentiment aware climate index, we have used three components. One is climate term weight, another is sentence level sentiment score, and I have also created the financial sentiment score from the news articles. This is the formula of climate term weight, and I classified the sentiment scores in three parts. One is positive, that is when the score is greater than 0.2, and negative for less than minus 0.2. And the sentiment score is calculated using the climate. I augmented the weather lexicon with the climate change vocabulary I have created in the earlier slides. And this is the formula of my climate change index. And I have also plotted the climate term weight and the climate change index versus the year. And to create the financial sentiment score, we used the Finbart model, and the financial index formula replicates the climate change index formula. And we have also plotted the the financial score, financial index score for the year, and we have seen that the pattern is not same for the climate index, and financial index differs over time. To capture the climate policy related information over the time, we also extracted the climate, if there is any mention of climate policy related term in the news using LLM Llama 3.18 billion, and we have found out that between 2016 and 2024 we have found almost 3,200 terms which are giving any relevant information for climate policy related update. And to evaluate our model, we are checking whether this climate index or climate financial sentiment index, they are actually reflecting any model to any, if they are giving any actually reflecting in the stock return, and and we are also calculating if their ability to construct a climate aware hedge portfolio. To what do I mean by climate aware hedge portfolio is we are giving more value to the climate aware, the climate friendly stocks like solar, the market where who are using climate friendly products like solar or solar resources, or compared to the uh, market which are using fossil fuels. This is we have plotted them, and we have found on 0.05 if correlation, which is not great, but we found out that when we are using the regression based sensitivity analysis, is our positive beta, we are getting positive beta for climate aligned farms, and negative beta for climate exposed farms, which are like fossil fuels. And we have also done the LSTM-based sensitivity analysis, and here we are why we are using LSTM, because it captures the temporal dependencies and non-linear climate market interactions, which we cannot capture using the OLS. And our input is rolling windows of stock return, and that climate in sentiment, our climate and financial index, and we are predicting the next day return prediction. So this is our stock sensitivity to CCI. As we can see that the sectors which are climate positive are getting in which are climate sensitive, they are giving positive sensitivity to CCI compared to the sectors which are vulnerable to climate change. They are giving negative sentiment. Our key observations are that we are giving a clear separation between climate positive and climate negative shocks, and climate sentiments are actually affecting the asset pricing. Our portfolio CCI, as we have seen from the graph, that our portfolio CCI correlation is modest, but our structure is climate aware, as we can see from the table. And LSTM captures the relationships missed by the linear models, as we can see from here. Like for oil and gas, they are the OLS is minus 0.01, but for LSTM, LSTM is actually reflecting that point. And climate change related policy updates affect financial sentiment. So our conclusion is climate change related policy updates are affecting the financial sentiment and stock market. So our limit, if we are going to our limitations, most glaring limitation is that we are getting a very low correlation strength, which is not good. So we think that if we elaborate on our news repository data and the stock market data, as we are using only 10 tickers, we think we can get a more improved result. And so our future work includes multi-source news and social media data, also considering the social media data, because it is nowadays it is becoming more and more important. And we are trying to use advanced time series architecture compared to LSTM. And so this is our goal, to elaborate on this.
Yeah, we have any questions from the audience?
Thank you, Priya. This was a very nice paper. I believe you basically followed the methodology of the Nobel laureate Robert Engels paper that you had preferred, but extended it by using more contemporary machine learning methods. So one of the things I want to ask you is, you mentioned the LSTM method is performing better, but I saw that one of the companies, which was a solar company, actually dropped its beta very heavily from highly positive to almost zero using LSTM. So how do you explain that, and how are you convinced that the LSTM model is better than the linear regression?
So actually, sir, I think that as we are for the weights, we are taking the final layer learned weights for LSTM, and as I have said that for many in some cases we are saying that, as you have said, that for some renewable energy stocks, the land weights are dropping dropping compared to the OLS method, but I think it is for the as I have only using 10 stocks, and only one Guardian news data, and sometimes the stock market is from USA, but the stocks are from USA, but Guardian is mostly based on UK region. The news is mostly based on UK region. So sometimes the information, the news are not reflecting correctly. So I think that may be the reason.
Okay, thank you. Any other question from the audience? Anybody online wants to ask a question? If not, let us thank her once again for the wonderful presentation. And now we move to the next talk, invited talk.
Yeah,
So I hand over the microphone to Thomas to chair this session.
thank you very much. Please, and we come to the speech of the day. Which is a great pleasure for me to introduce this conference, which is Germany, including the PhD in Duisburg Essen, and his PhD supervisor, Mr. Robert Moore, is the most renowned IR scholar in Germany. So it's a great achievement to work in his school for Igor. He later went to UK and spent years, I think, in UK various places, and among them was researcher, which is actually the place as the Benfield College. And Benfield is an important name in our community. So he was really there and did the spirit of Benfield, I guess, in researcher. And now he's recently, 1 year? Okay, so very recently he changed back to the continent of Europe and is now in Bonn University, right, in Vienna, very nice place, university. And his research has covered several topics, access to scientific information, bibliographic research, also very known for quantum IR, and several others. So we are very at least now, actually, some information. Yeah, so relevant for everybody here, I guess. So this I will end, and thank you for being here, and please we are happy to hear. Thank you.
Thank you. Yeah, it's a really great pleasure to be here. For me, it's the first time in India, and yeah, very amazing place here. Good time, my colleagues. What more could you ask me? Okay, so thanks for the nice introduction, Thomas. So yes, my talk will be about information overload in academia and about. So if you don't know Modular University, we are a small private university in Austria, in Vienna, and this is actually with 700 students, and this is our entrance. If you're not impressed by that already, you might be impressed by the views we have in Vienna. So if you're around, please come and we can have a coffee and enjoy the view. Yeah. So, okay. What I'm talking to about today was actually in the news a few weeks ago. In the Guardian, there was an article about AI researchers a slot problem, and it was about a researcher who has written over 100 papers in 1 year, and they got a bit suspicious. And but the article was also about the flood of applications and that people can't keep up, and the quality of lots of research. So really reach the mainstream press. So what am I going to talk about? I'm in an EU Stock Exchange project, which is about information overload. And I found that quite interesting because information overload is something that we as IR researchers
try to tackle in a way. Right? Because we want to provide users with relevant information to their information need and filter out everything that's not relevant. So we'll talk quickly about what is information overload, then how do we perceive it in academia. As I mentioned, IR is a kind of solution for that. I will focus on scholarly information access and how to tackle information overload, looking at relevance but also quality, and then some ideas I have in mind how we can move forward. What are the challenges and possible future work? So, what is information overload? So, information overload, there are several definitions. One that I like is that situation which arises when there's too much relevant and potentially useful information available that it becomes a hindrance rather than a help. So, in the 70s, the problem was that we couldn't find information because it wasn't there. Now we have it, but we kind of sometimes can't use it because there's just too much. And there's a link between too much information and also our limited human cognitive capacity, and that might lead to a negative psychological state, and in which people feel they receive too much information to carry out that task. That is the general definition, and you might think about social media and all the information available in general. And it has several consequences. It limits our ability to evaluate information and then decreases our decision performance. It might even reduce social activities and all these things, and that it can lead to demotivation. And in some study that we got out, it had even economic impact. So they talk about global cost of $1 trillion per year. We wrote a paper about that in our project, where we regarded information overload as a kind of study, and space, the information space, kind of needs to be protected, and like we protect air, water, and soil. And as I said, information retrieval could be one remedy of information overload. So let's have a look at information overload in academia. And so there were some papers that particularly were published during the pandemic, that we have a challenge here, that we want to find relevant research which the guy called Brainerd calls application tsunami. And so we have this huge wave of papers that kind of we have flooded from that. And if we look at statistics, so here are some from Dimensions, about the AI and machine learning applications. So it goes exponentially up from 2016. Probably can continue that curve now. On arXiv, there is similar observation in computer science publications, similar shape. The idea why I found this topic quite interesting came also during the pandemic, because they made COVID, we had to find a remedy, a vaccine, and these kind of things quickly. We couldn't wait for long peer review turnaround time, so they published on preprint servers, and lots of studies were published. So we have a similar curve here for COVID and for the biomedical domain. So that's it's not just us with AI papers flooded, but it's also other disciplines. Yes. So what's the problem? One paper, here's one example of a problem where a certain data set, the National Health and Nutrition Examination Survey, which is, I think, available also since the 70s or so. I'm not an expert here. And they found that papers using this data set have risen by 2024. So they had 4,800 papers in 2023, and then 2024 it almost doubled. And they also looked, then some experts looked at papers and that study kind of very simple associations only, vitamin D and cancer or something like that. And they figured out that these simple associations in 2014 to 2022, they found 4 papers, and then in 2024, 190 papers. That just the low-hanging fruits in a way, if you want. And that coincides with the availability of ChatGPT, and then they looked at some of these studies, because that author is also an expert in depression, and they said, yeah, but many of these studies wouldn't survive some statistical adjustment that you designed to control the risk of false discoveries. Don't ask me about details, how that good, that's not my area of expertise, but they conclude this is low quality. Okay, and then also there's a possible link, I come to that, to paper mills, and also this pressure for web application that emphasizes quantity before quality. So it's a kind of industrialization of low quality research that also contributes to information overload. Recently, Archive Computer Science announced that they don't accept these kind of survey papers anymore, because they said, yeah, well, they're easily, LLM can easily create them, and usually they don't contribute much. So there are little more than annotated bibliographies, and there's no substantial discussions, and the moderators are overwhelmed by that. So they said, okay, if you submit a survey paper, it has to be accepted at some conference or journal before. That's of course critically debated, but that's a measure that they take just to keep up with the number of survey papers that are published. Okay, and so what we see here, we see that information overload is caused by the volume of publications, and if we look at FHIR this year, we have this SkyHive, right, which kind of picks up that idea that there are too many, or the volume of applications is too high, and so we want to highlight scientific contributions here, which might be also a way to reduce overload. And we have this application tsunami with low quality. What did I write that? Okay, anyway, and it's not only on premium servers, so there's a high number also of retraction papers by publishers. So it's not just kind of premium servers because they're not so peer reviewed, but also peer reviewed publications sometimes suffer from that. And we think that finding these cases is critical because it contributes to information overload, but it also involves the trust in research in general. And we have examples from the pandemic, for example, we had this discussion, should I wear a mask, no or not? Initially they said, no, you don't have to, then they said you have to, and because there was new evidence, understood it like, they don't know what they are talking about. So, what are challenges? There are some challenges that I'd like to show here. What places, auto-generated papers, and called fake science. So, what are project phrases? So, project phrases are phrases that are incorrectly used instead of the correct ones, for instance, to avoid plagiarism detection. And my friend and colleague Guillaume Cabanach, I think he even coined that phrase. One of his missions is to detect important phrases, and he wrote some books about that. And here are some examples of these important phrases. So instead of writing a neural network, you would write a neural organization, or artificial intelligence becomes a human-made consciousness. And so you could probably make a writing game out of that, right? So just guess what this torture phrase actually means. So it's very funny. So personal information, data. So these are phrases that I really discovered in publications. And we have one example here of an AI-generated or potentially AI-generated paper that was accepted and published in Elsevier Services and Interfaces in March 2024, and the production starts with certainly here the personal interaction for interface. And it ends with regenerate response. So that somehow survived the reviewing process, okay, but it was retracted from the data. Because also there's this the web page up here where you can where they discuss these cases of fraudulent papers or potentially fraudulent papers. So question here is the whole paper auto-generated, or did they just use some writing help? We don't know, but it raises the question of the quality of research papers in general. Then we have that problem of papers. So these are industry scale production of manuscripts and authorships, and so it's often fabricated data, and some have manipulated peer review, so that's kind of a click of researchers, they review each other in a way, and also that contributes to information overload in the most must. In this example, in this web page, here maybe. So this is a screenshot of a web page. I don't put the URL there, but what you can do is they have papers, types of papers, even an abstract. They say we want to submit it here and here, and in this case, for $960 US, you can be the first author. Yeah. These pages exist. Okay, you can buy your authorship. As I said, you won't find a link for me because I don't want to encourage anyone here. So, but yeah, there's lots of problems. And that's, of course, it's kind of a cause of this pressure that you probably feel push or perish. Yeah. And I have this kind of fake science detection, a bit fake news detection, which is related, but there are some differences. For instance, in fake news, you usually have a kind of ground truth. You know what, if the house is burning or not. In science, that's a bit more difficult because, of course, it can be really credible scientific results, but then we have to repeat experiments or things. So it's a bit, I think it's not so easy to figure out what is here, what is made up. Okay, that leads me to the second part about scholarly information access. And as I said, I think we need effective IR methods to tackle this problem of information overload. And I also think that just looking for relevance is not enough. So we should also determine the quality of scholarly documents. Now, the question is, how can a layperson, let's say a journalist who wants to write an article about, let's say, AI, how can they figure out what is high quality or not if they're not a trained researcher? And so the idea is to look at, okay, how can we determine, maybe by help of AI and LLMs, or give at least indication about this is a high quality paper, if this isn't. And also for our researchers, guys, if we go on archive, if we can have a filter that filters out what's perceived as, well, you don't have to read this. So let's look at relevance first. And one of the areas I've been working on is method enhanced information retrieval, which means we use bibliometric and psychometric measures to enhance the retrieval process. And so it's a very nice, lots of data to play with. We like to play with data, right? So we can look at citation networks, co-authorship networks, impact factors, so-called alt metrics, that is the impact of a paper that's on social media, people tweet about that, etc., for example, and other scientific indicators. And also we have a special structure that I call, or not I, but others call, the INVET structure of scientific documents. INVET stands for Introduction, Methodology, Result, Analysis, and Discussion. And in these different parts of a research paper, you usually find different kinds of information. And here's an example about bibliometric indicators and relevance, how they calculate. It was a paper that was submitted to our peer workshop a few years ago by Jacqueline Sachse. And we looked at relevance criteria like quality, validity, accuracy, source reputation, etc. And how users assess this criteria by examining some properties like the abstract, author's journal publication date, and that is influenced by relevance factor, but like knowledge level, content novelty, document novelty, etc., etc. So that is quite interesting how bibliometric indicators and relevance might be related. We did some work 10 years ago now, so do some new work on bibliometric enhanced information retrieval. My then PhD student, Kevin Lavasi, worked on that. And in that picture, you see many concepts in one approach. So we use the method for polyrepresentation together with probabilistic clustering in simulated users in that approach. So what we did, polyrepresentation means we represent documents differently. So for scientific papers, it would be the representation given by the content of the document, but also by the metadata as a different representation, and for instance, the citation context. So what do the cite the paper write about this paper? So these are different representations of the document. And representation dictates more or less, or says that if a paper is relevant to all these representations, or a document is relevant to all these representations, it will be relevant at all. There's a whole project theory behind it, and but some experiments have shown that in this set where so you can this would be the set of documents that are relevant to all representations, and you find a high precision. Okay, and so we can create clusters on that. So this is the cluster of documents that are relevant to all representations. R2 would be the cluster of documents that is, R2, 3 would be the cluster of documents relevant to content and some metadata, for example. And this way we can create clusters, we can do cluster ranking, what we did, and then we had an assumption of the user, so that the user, in this case, a very, very simple assumption, that the user looks at the first 5 documents in each cluster and then moves on to the next cluster. And this way we get an actual linear ranking. And we could then, at that time, BM25 was a thing, compare it to BM25, got statistically significant better results. That was nice. So it's one example on how you can use qualitative indicators. Another more recent work in our project, in our own project, was a study that we did with our partners in Cologne, GESIS, Social Science Institute, where we looked at summaries of rankings. So people, social scientists, they have a search engine for social scientists, and we just said, okay, let's use AI to create a summary of the search results. The idea is how it relates to information overload, that we hypothesize that with this summary of search results, researchers would be, or users would be able to more quickly determine if the result is actually what they're looking for, or if they should start the search again. And so we created that summary that you see there, in this example in German, but then we did an experiment and asked, okay, first of all, how accurate are these AI generated summaries? We all know about large language models, hallucination, and all these problems, and are frequent error types. And then we asked, okay, can they actually do they actually work? Can they support social scientists doing their search in an academic search? So we had as I said, it's a collaboration with colleagues in Cologne, and we had some data set that we used, that they have 1,000 publications, and also some studies, not just publications, that they have. And when it comes to the accuracy of the summary, we found, okay, we have models, GPT for Omni and Llama for Scout, and just had an evaluation by experts of 10 of them, but maybe then quite partially quite incorrect. It's a small study, I have to say. And GPT 5 were labeled as correct, and only 1 is incorrect. And so 9 out of 10 were either correct or partially correct. Llama didn't perform that well. They were only they were correct only, and then 8 partially correct. But then the errors that we figured out was there were some inaccurate or unsupported content descriptions. There were unsubstantiated guesses or speculations about what the user actually wants. There were some search results which were ignored. There were then incorrect study identified that something internal for cases for the database, so incorrect links if you want. And also in the of studies. So we created some we had some groups of studies, and some were just misclassified. Okay, and when it comes to our other research question, does it help? We had 30 participants with a social science background, and we didn't get statistically significant results. We got indication that some of these might reduce the mental effort without negatively affecting the subjective workload, because of course it's a new piece of text that normally isn't there, so you have to keep it. So it might even give you more workload in a way. But our results were this. There's an indication, but conclude, I think we need more studies here, and hopefully get more significant results. But it's a start, and at least it doesn't do any harm. That's what we also figured out. Okay, let's talk about the quality. That I was thinking, how much time that? Okay, so I need your help. So I would like to ask you, what are your criteria to judge the quality of research? So I have prepared the survey here, which you can, if you scan your QR code on your phone, quickly do, where I just ask you to type in some keywords. If you read a research paper, how do you determine if it's a good one or not a good one? What are your criteria? Maybe give a minute or so, then. I've something as well, so I'll see the results. Okay. So you can continue, I will continue the presentation and then we will later again. Okay. Right. Okay, good. Of course, we are not the first ones to ask this question. So, one paper that was for a slightly different topic, this year they identified some criteria like peer review status, citation impact, experimental and methodological rigor and transparency, venue reputation, etc., etc. So, the thing is that not all of these signals are available for new publications or papers. When it comes to citation impact, new paper doesn't have that yet. Right? So then in the UK, they have this every 7 years or so the exercise that drives some people crazy. Called the Research Excellence Framework, which is very important because a university that does well in the web gets more money from the government. Simple as that. And it's a good argument also to speak to your senior management that research is important because if it means money, then it must be important. There's some universities who value research a bit less than others. Anyway, and they identified 3 criteria, main criteria: originality, significance, and rigor. And then usually judges what would you do is each university submits papers, right? And they don't look at age index and these kind of things. They're not allowed to. They really, judges have to read these papers and then judge them regarding to these 3 criteria. From 1 star to 4 star. So foresight, what we want, world leading, and all of that, as I said, we create money. Okay. Now, my former colleague in Wolverhampton, Snow Sheffield, my fellow, he very well known in the scientific community. He asked, okay, can we use then LLMs as reliable estimators? So what he did is he did self-evaluation of 51 of his publications, some that were accepted, some that were not accepted. And he tried also to be as objective as possible for self-evaluation. And then he asked ChatGPT several rounds. And so he asked ChatGPT first to search all the papers, and then he did another round, because he needed kind of adjustment first. And what he found is, yes, that ChatGPT provided consistent quality assessments, but also tends to overestimate quality levels. And I did a check myself once, and I agree with that. And we can see here that's an image taken from one of these papers. ChatGPT mainly is in the middle range, right? Somewhere in 3, most of the papers. Whereas the x-axis is its own evaluation of his papers. And, so he found that ChatGPT is a bit too optimistic. A similar study looked at reviews, and so they looked at they asked ChatGPT to, or I think it was ChatGPT, any LLM, to provide reviews and judge papers according to certain criteria like soundness, substance, clarity, originality, etc., etc. Typical properties. We look at the review, and on the top there you see that's the reference, that's the number of documents that were judged positively or negatively with respect to this criteria. So the top is the human assessment, the reference, and then they different ChatGPT or different large language model configurations. And one can also see that if you look at it, that when there's a plus here, then ChatGPT more or less gave better scores most of the time. So that's the wrap up of this this study. So the feedback, they also found that the feedback is often positive, and LLMs also prioritize different aspects. So they concluded that LLMs are, at least as of now, not really reliable reviewers. So they can assist, that's what I conclude from this, they can assist in quality assessment. They do not depend on citation data, that's quite nice because they really look at the paper. They seem to be overly optimistic. It might be that this is not a problem if you want to use them for a kind of initial screening of quality. Maybe it's not a problem. But of course, for use or hiring committees, you shouldn't use that. Another interesting part that I found interesting is the scientific fact checking. What happens here is you have a claim like Homer Simpson is a cartoon character on Seinfeld, I think that was, and what you use here is kind of wax solution. So you retrieve documents that can potentially answer your question or that claim or verify that claim, and then you feed it into an LLM, and then it will give you either tell you true or false, more or less. And we can use that also if there are claims in papers. We can of course use that to verify these claims. So, how can we use that scientific fact checking in quality assessment? For scientific fact checking requires qualitative evidence. Yeah, this is the people part where you need documents that can verify your claim. They need to be high standard as well. Otherwise, of course, it doesn't work. But on the other hand, you can use fact checking also to assess the quality of scholarly documents by verifying the claims that are made within a publication, for example. And also, fact checking should take the document structure, the email structure into account, and also look at multimodal content. That's something that hasn't happened so much yet, because evidence might be in figures and tables, and they need to be interpreted as well. They might be also useful to identify internally inconsistent signals. So an author might make a claim in an introduction, then you have the evaluation, and then you read the limitation section and you see, okay, but that claim is not really supported because of too many limitations or so, right? The authors will probably often say, yeah, we found evidence for our claim, but then if you read the limitations or maybe externally verify some things, then you might figure out, nah, maybe not. That's something what a reviewer probably would do as well. So that's why I think it might be interesting, fact checking might be an interesting method also to verify the quality of solutions. Oh yeah, this is also some work that we did with my PhD in Kanishka Silva, where we looked at can we detect AI-generated papers. That's some work. We used writing styles and then into a transformer model, and then we generated abstracts from papers automatically. What we wanted to do is, can we detect if an abstract was automatically generated or not, and it worked quite well. Some other. Okay. So, summarize that part. How can we tackle information overload with scholarly information access? We can use bibliometric enhanced information retrieval, where we use that, where we look at scientific signals and data, citations, co-authorships, impact factor, fault metrics, etc. In general, I think LLMs and AI can assist in quality assessment, but it's really just assistance and not decision making. And they need those supervision. Okay, so that's the last part. Some challenges and some ideas we should look at when we scholarly information access. We provide some solutions, and if we look at some of the challenges for academic information access, first of all, we have a heterogeneous user group very often. We have senior scholars, we've got students, we've got maybe journalists, we've got what I call the interested public. So some systems are specialized, of course, for researchers, but of course, we disseminate scientific results. We might create a search engine for everybody, in a way. I think that finding relevant applications is not enough, so we need to guide users and provide them with indicators for quality and impact of applications. In general, systems should be more user-friendly because there's no one-size-fits-all. We've got different disciplines, different user groups, they've got different demands. And another thing is they should be interactive with the user in control. So we have this notion of human in like to push that a bit forward and call it machine in the loop, because then it would be clear that the AI in the machine is a tool that we use. The human who controls it. So human in the loop sometimes sounds a bit deep, like, well, yeah, the AI is doing something. Sometimes, unfortunately, the AI needs human intervention, like providing some labels or so, yeah, can go away. And I think we should really let the user be in control. And there needs to be multi-model scholarly document processing, because we have tables, we've got figures, different data from text. We need tailored data sets for evaluation. For instance, Jack Meyer and colleagues from Omnium project, they published a data set now where they looked at archive documents and linked them to published journal publications, so you could figure out which of these preprints were actually of high quality enough to survive a peer review process and were published in the end, and which were. And it's also required evaluation initiatives, shared tasks like SciHi and maybe others. So, when it comes to the user, I think we should see the user in context. And this is one of my favorite images from the book The Turn by Ingerson and Kaeberlein. And here you see informational table, like we know it, in the IR context. I could put an AI symbol here as well these days. And IR is in a seeking context, in information seeking and searching. And we should always consider that, which again is embedded in another context, the work task. And there might be even socio-organizational and even cultural issues, right, that we might consider. And that also means that we have different evaluation criteria on these different levels. That's something that I think also when I observe the really good publications here and presentations, but it was always, we do an LLM for that or machine learning model for that. I just wonder, okay, but where's the user? Yeah. So that might be something that comes. And along with that, good old information seeking strategies, Belkin's work, and others, which was picked up by Chirag Shah and Emily Bender recently in a paper, where they argued, okay, we should evaluate can chatbots, conversational agents support different so-called information seeking strategies. They define the method of search, the goal of search. If an LLM provides you with answers, but as scholars we want to learn, how does an LLM or a chatbot support learning, for example? Then the more to recognize or specify our information need and the resources, that is metadata and information here. So everything is normally a continuum, and you would in a search session maybe switch between different strategies. But that's something that is still used today, kind of evaluate systems. How user-friendly, how much user interaction, and how do they support information seeking action. So then in general, we need to define classification quality criteria, like the Web did, like we did in our little experiment, I come to that. And also different disciplines have different criteria. We should not forget that. We might integrate to estimate quality, econometric and psychometric signals. Then, and I think certainly we should use NLP and LLMs to extract these signals from scholarly documents. I mentioned claim verification. What I think we should do when we become more interactive, because all these approaches now have a pipeline from left to right, and we can use claim verification. For instance, if we have different claims in the paper, we might extract them, verify them, and then get some values if they are reputed or supported or neutral. And so that might be another tool that we can use to estimate the quality. And just how do we report this? Should we just tell people, yeah, this is high quality, this is low quality? I don't think so. I think we should let the user decide in the end. And there was one paper also 10 years ago, I think, by Norbert Fuhr and some others, where they talk about information nutritional labels. So that comes from the context of fake news detection, where you, with articles, not should tell the user, oh no, this is fake news what you're reading here, yeah, but like nutrition labels on your glass of marmalade or so, it will tell you, okay, in this case, it has a certain content is 30% fact, 40% opinion, a bit of controversy, emotion, topicality level, and so on and so on. And in that paper, they describe how you could, with technology 10 years ago, detect and determine these values. Something like that I find interesting, because it gives the user control in the end, but also quickly some information at hand to determine the quality of papers. Then another thing that I'd like to talk about is rank. I mean, many of these approaches, also claim verification, more or less like this. So if we use retrieval augmented generation, where we use a search engine to enrich a large language model to keep it from hallucination, to provide it with up-to-date information or domain-specific information. And if I look at these rank approaches, they're mainly lexical, which could be in 25, or there's semantic search with embedding vectors. Sometimes dual link types used. Sometimes. But in a way, we have these decades of IR research where we came up with completely different models. And I think it might be interesting to look at, can we reuse them? I mean, we are now in an age where the user of our search engine might not be human anymore. Might be an AI agent, for example. So we have this really, many models, and I'd like to give two examples from my own work, because I always did a bit of logic stuff, the way, which is symbolic AI and AI and user interaction with tangent probabilities. I don't go too much into detail here, don't go. So my PhD work was about what you these days call hybrid AI, or you would call symbolic AI, and we can use that in a hybrid setting where we combine that with LLMs, for example. One of the advantages of that is that we can potentially improve the explainability of that. So what I did in my work 100 years ago was use so-called four-way logics, where you have use values, false, inconsistent, unknown, and use an open world assumption. And when I looked at the flavor verification, I thought, yeah, but you get a value of probability for support with not enough information. You can map that to these four truth values in the end. And so why not have a new symbolic setting and apply these technologies or these paradigms, these logics, together with large language models, for example. In Austria, there was a call about hybrid AI recently. where you submitted so I think that's an interesting direction as well. The other one was my work that I did as a postdoc in Glasgow, later as well. Was about quantum models, where we looked at a search engine similar to a quantum probabilistic system or a quantum mechanic system. So we would operate here on Hilbert spaces and well, we've got embedding spaces, we've got vectors. Hey, great. So you have vectors and an inner product, then you have Hilbert spaces, then you can do quantum probabilities, because quantum probabilities are based on geometry and Hilbert spaces. And if you do, so you can do geometry with it, you can do probability theory with it, and you get quantum logic for free. So all of this combined in one format. It's fantastic. And in our work, we showed how you can describe documents, for instance, not as vectors, but as subspaces, which are description that, for instance, preserve the logical document structure. And then you have this idea of different state vectors that you can use to express the uncertainty of information need. When I type in Java in the search engine, do I mean an island, copy, or a programming language that you can model with that? And then user interaction and state changes can be represented through metadata, for example. They change, so each interaction that we observe, the user changes the state of the system. And then we have other things like interference, complex numbers, and all that machinery. And one of the things that I'd like to look at one point, if I have time ever, is to really run this on embedding spaces and see how far we get with that in a web setting, for example, in an interactive web setting. Okay, so this will of course help that different kinds of users find, assess, and understand scholarly documents. Also, will this help cope with the information overload? And now I'm almost finished. So I talked a little about information overload in academia as a significant challenge that requires IR and information access solutions. Should then not estimate just relevance, but also quality. And we should think all of the box. We should take the user into account. We should maybe go beyond semantic search, EU25, and maybe see if some of the other IR machinery and models potentially apply here. I'm not finished yet. Sorry. I'm advertising. One thing is for our Colia workshop at ECR in Delft. So if you work in scholarly information access, that might be interesting for you. So it's the successor of our bibliometrically enhanced information retrieval workshops, and our whole was deadline is 19th of January, but it probably extended. And we also look for shared tasks. If you want to submit a shared task that would then be presented at Scholia 2027, then yeah, please visit our website so you find more details there. The other thing, but that you can do maybe later, we in our information overload project ONVO, we created a survey where we want to understand information overload and if you are overloaded. So if you like, please go to our website, and do our survey. That would be fantastic. That. And, yeah, some time to take a picture. Okay. And that's it. Another view. That's from my walk down to Vienna from my university. Yeah, the vineyards and this. Yeah, I'm finished now. Thank you very much. Questions?
Thanks a lot for the presentation, and you perfectly emulated the inner thoughts that we were having during this law data. So this year only the Merriam-Webster declared sloth as the word of the year, and that was in context to social media sloth what's been going on. In academia, the sloth that we are seeing, will it also have similar kind of migratory effects in the upcoming generation of researchers? What is your opinion on that?
I think potentially yes. If you ask me for an opinion, it's not a fact. So I could imagine it, yes. I mean, we're kind of seeing it. During the pandemic, we had it that we told people then, yeah, but look at the science, right? And then people came with some lovely study that vaccines are harmful or whatever, yeah. And said, yeah, here we look at the science. They say you shouldn't get vaccinated, yeah. And so it happened already in a way, yeah. At least for the general public, of course, we as experts, of course, we have different range of opinions, and of course, there are also researchers who are think climate change isn't a thing, and so yeah, of course, even scholars have different opinions, and it's also good in a way, yeah, because science means that we are most critical to our own work as scientists. Yeah, we are the most critical to science, and that's good. I mean, if we educate researchers, then I'm very optimistic that this can be avoided. At least for the general public, I think I see some danger here, and we should do something about it. Thanks a lot.
Yeah, thanks a lot. That was a great talk. Obviously, you presented it in a very good framework and all the methodologies to evaluate quality. And finally, you said that it should be left to the user, which makes a lot of sense. But still, as part of this system, what are the risks of the quality assessment being wrong? Because there's always bad results. So some very good article could be classified as a bad one, or vice versa. So what are your recommendations in terms of the course of that or improving?
I think for that, explainability is very important. Not just to give these even the nutritional labels, but then provide, if users need it, provide more information. And of course, things can be wrong, and nothing's ever free. But again, I think the key is to let the user decide, because otherwise, imagine the alternative, a large language model telling you with authority, yes, this is indeed a low quality, or this is indeed great work, yeah. And so I think in the end, my paradigm is really let the user decide. Now we could argue, but then I also say we should want to reduce information overload, but that means more cognitive load on the user, which is also true. Sometimes you cannot avoid it, but yeah, I would say, of course, we need evaluation initiatives and all these things for the quality, but nothing's, of course, ever free. And maybe time will tell that if the paper that was maybe judged as low quality, but then becomes lots of citations and has an impact, of course, later. Yeah. Although you might say, okay, but if it's initially deemed as low quality, you might never get citations, but yeah, it's, I think in the end, I would always say we should we should be transparent and explain results.
Yeah, thanks, Nico. I've been taking some photographs of your slides. It was really just a comment. I've been quite struck with one or two of my students. I think because of GPT, they are, I'm encountering a new kind of problem with my students, which is they're writing too much. And that's never been a problem until now, because writing is hard. I mean, particularly because pretty much all of the students that come to RMIT, English is a second language, and so it's incredible that they can write academic papers in the second language. But now, so because it was so hard, they would basically only tell me the important stuff, but that's not happening. So it was really a comment. So it's not just the volume of paper, it's also the length. So I'm having to teach them how to cut back in a way that I used to get for free because writing was so hard. Just
Yeah, but true, yes, it's a good comment actually. I think maybe if it's the fact it's high track and then also what Jaap presented can be helpful in that respect to kind of distill the real information. Yeah.
Yeah, just a follow-up comment. Since I work in AI in law, I've been talking to lawyers and see that Indian high courts and Supreme Courts have all the proceedings mandatory to be in English. But in the lower courts, they are in vernacular language. Most of the lawyers also like here English is a second language in most of the cases. So writing a good draft, compelling draft that will convince the judge is not that easy if it is if it has to be in English. Now, what GPT is doing, just the other side of just what you mentioned, it is empowering people who is otherwise smart legally, but is not able to write down the drafts because their English is not that good because it's not their first language, right? Now it is making them better lawyers. That's what the lawyers are doing. Anyway, just a, comment.
So I take your point. I think that's fantastic. One thing I was going to say was at ACL, there's been this incredible explosion of paper coming out of China. And I think what's happening is, a lot of the top Chinese universities, a lot of those academics can speak English, they're very, very good at English, but a lot of the Chinese universities, they're not so good at English. I suspect GPT has unlocked that ability to publish in English. And, there's some decent research out there to be done through a lot of universities. And so, yeah, I think you're right. I think there's a bunch of those examples. I think what's interesting though is it challenges some of the systems, some of these systems that we have where only the smart lawyers who could also speak English very well get to do things. And I'm not saying you don't want the situation you're describing, but it may challenge some of the systems we have. Some of those systems may have inbuilt assumptions, and it's a bit like that with ACL, that these conferences are getting overwhelmed with content, which might be very good, but it's just sort of challenging some of the systems we had. There were lots of implicit assumptions.
Comment and comment on comment and comment on comment on comment. Yes, last one. Recently, actually, I was scraping all the different papers from archive, and I found that the writing style and the words that are used, the semantic similarity between papers from even across physics to computer science have this thought process being almost similar, and that
indicates that they are using some kind of LLMs. But comment on the Chinese universities as well, they are using their own models. There I found that their models like the DeepSeek or even the Kimi K2 model, their writing style is so much different that they are adding personalities or personas in their models. That diverses out the writing style. So it is again, Dr. Ingo's part, it's becoming way more difficult to even detect is it being written by AI or human in that case. Thank you.
I mean, when it comes to the AI generated, of course, some might also ask, is it a bad thing? I read some paper from the Waxis community by Joran Dehlen and others, where they argue we should more or less try to automate the whole research process, from ideation to publication. It's a bit extreme, if you ask me, in particular when it comes to ideation and stuff. But certainly something to think about. Why not discussing that, right? And so question is if it empowers people who are non-native speakers to write good papers, that is not a bad thing.
Thank you very much for the talk again. Thank you also for the discussion. And before we go to the break, we would like a small present to Ingo. Coming and delivering the page. Like to give a small comment on it. Then we can have tea break.
11:15 can start. 11:15.
11:15, please be back.
I'm actually not sure that my papers can be created overall. Yeah.
So, okay.
Hello everyone, good morning. I am Moyet Ghosh, one of the HASHOP organizer. And first our overview presentation will take place, then the presentation for the participants will be there. And first I would like to invite Professor Thomas Mandel sir for the overview presentation, who is the one of the main organizer of the HASHOP track as well as the section chair of this section of this session. And over to this.
Okay, thank you very much, Brielle, and very welcome for this overview of HASSOP. And this time, this year, HASSOP for the first year, visual content, multimodal content means text and audio. So we see the team here, definitely most work was done by Brielle, and so thank you very much to her. I'm just basically doing the presentation. See now we can change the lines. Okay, now I found it. So the overview of the content of this talk, we'll have only 5 minutes for these 30 topics here. We'll give a short overview, annotation, training testing, statistics, some participation results. So let's look back at the history of HASSOP. We had that a long time now, 7th edition. We started with 6 years text. We see that we have 12 languages. We have more than 120, 60 papers published only at the workshop proceedings. There are so many people who reuse the data, and this is, I think, from this perspective, quite successful. We contributed to many other papers that are published in other venues as well. So we see we have 5 tasks. We have a visualization of our 5 tasks. We have first the sentiment detection, positive, negative, neutral, euphoria, sarcasm detection. Does the person really mean what they say, or do they actually mean the opposite? And want to just be sarcastic. Vulgarity detection, abuse detection, number 4, that's kind of the free speech label that we have given. So the labels were given on these 5 labels. And the 5th one was then later dropped, because the labels were just too imbalanced, something we could not predict. We started off with this, but it turned out not to work on that. Sense. Obviously, we think of targeted groups, politicians, females, migrants, religious groups, but in this case, we did not have classes didn't come up that made a big gap. Here are the explicit definitions, more details, but I think it's already more or less clear. I will go on. Here are some of the examples, and we see without proper knowledge of the language, it's not possible to detect the faithfulness and the intention behind these needs. And also you need cultural knowledge, you need to know about what these people who signify in the local culture. Who is this person? Is it a politician? Does he have a story behind something that happened recently? And what does the text mean? And again, the same thing. So you need a lot of local cultural knowledge and also the linguistic knowledge by this day. So that makes it again very, very difficult for systems, for AI to make such. Here is a test training screen for the 4 languages. You also see the size already of the data sets. Here we have blue is training, yellow, orange is testing. And we see that we have either thousands of annotated. We organize the process with some volunteers and students, so quite some time and some efforts with the help also of we have to find people who really speak the language and understand the content. Here we see the quantitative overview. We see that we have 1,000 means for some of the languages, abusive, non-abusive, abusive categories, not so minor, such minor classes, of course, sampling, that's always an issue with the hate speech data sets, but also in the sampling, of course, we specifically look for such probability. And here are here is again a graph. You see display, you can see the diverse languages, in this case, for the labels, sentiment, sarcasm, use, and vulgarity. We see the distribution of the different languages. And of course, sometimes we can have data that is as a positive sentiment, sometimes it can be a negative sentiment, sarcasm can be involved or not. So it makes sense to label these categories independently. So we had again a good participation, a lot of interest in the community, 45 groups registered. However, only 20 unique groups participated, and I think we ended up with 70 papers submitted. So we see that some teams did several languages, some teams only did some languages, but most teams did at least more than one language, and 306 of course, there's always a line for 45 to 20, it's some decline, but of course, multimodal data is a little bit more challenging. Today it's much easier than 20 years ago, but still, this was also a barrier, and we couldn't catch all the features. So maybe we see if we continue, then we might successful then. So the evaluation, we have the 5 categories, the 5th is drop, and we have 4 first check for each of these 4 tasks. The systems have to give a score or a label, and the final score that we did the rating on was simply the average of these 4 scores that were calculated for each of the 4 tasks. So there is, of course, some more interesting data even behind this average, and we will look into this in the future. But for the ranking that we have, we also gave a baseline to allow create a lower entry barrier. Maybe also next year we might give a different score-based baseline. But this year we simply gave a prompt and ran a system to see what would be a zero-shot baseline. And we see here the first result table. This is for Gali or Mengla, and we see that the baseline is around F4, which is 0.5, and we see most teams actually are better, and also have quite a range of scores, and the highest score also only 0.6. We have seen better results in any other hate speech tasks, but this is again low resource, where we can clearly see that the performance is not as good as for some English. Same for Hindi, again baseline number 11, we have 17 submissions, and again, we are reaching the same level of performance at Vonage around 6.1. And we have some, again, single shot. Gujarati, same thing, basically, baseline is here. Lower, and have a quite smooth conditions where people want Gujarati. And the total, well, you have the smallest amount of data. Here, the baseline is scored lowest. Everybody is above the baseline, all the submissions. And again, we reach around 6 benchmark information. So again, when we reminded this is the average of the 4 individual tasks. Yeah, Outlook, we decided about the task and we might continue. Our aim would be to add one more language, maybe Telugu, so South Indian language. We also try to continue with at least 1 or 2 of the 4 languages that we have now. There is some additional testing data. If use this data as training data, and then we run the task. If there's any queries, you can ask us now, of course, but if you have something later, you can also contact us via email. And with that, again, thanks to the whole team, acknowledge to the workers, to the annotators, and everything, especially to Coelho, of course, who did most of the references, and the organizers again. And thank you very much for your attention. Any questions at this point? You, please.
Your attack on the data set. Yeah, before that. Yes.
Okay.
That's all. We have a higher number of stochastic than non-stochastic ones. Is that a realistic balance, or is that?
Seems to be, but I think it's very common that people say something that they don't mean. Actually, they mean ironic, and trying to convey a message. So, with our sampling, we cannot say that this is represents during the social media, but it seems to be maybe special needs.
Interesting.
I guess I was just wondering, so you're studying these 4 things against these languages. Did anything jump out about a particular language? Is there anything that's, it looked to me like the scores were not that different across each of the languages. So is there anything unique about the languages in this particular context?
Yes, I haven't seen anything that it's really, there were languages, one language speaks out, maybe Korean, do you have
Actually, I didn't get the question. Can you ask?
Well, you're studying different languages and you're studying detection of hate speech. Is detection easier or harder in some languages than others?
Sir, actually, most of the work is done in English, etc. So now we are starting with the low resource languages. So whenever model is seeing anything, that is everything is length. So I don't know it is based on the language or not, but as the resource is very less, so less detection is there for low resource languages. That I consider.
something, yeah, you should want to explore looking at parts. Part is that what are the schools, what are the subjects, about the differences. So we still have to dive into the analysis of the solution. Yeah, and so we haven't that are really important. Another question, yes, please.
Sir, usually in memes, there are multiple memes wherein there is no language actually written. So just by, let's say, some movie character, we kind of try to intend something. So how are we actually handling those cases here as well, or it's mostly the memes wherein something is written or something like that?
I think we only use
Yes, actually intentionally we keep some images which doesn't have any text, etc. To see that, I mean, prompt with the prompt LLMs can understand what is going through the image and what is the context of the image. Because most of the time, whenever people are making a meme, so only through the image they are conveying some message. So that samples are also there. So it is intentional thing that we keep those kind of examples.
So they're probably 10% or less.
It's not more than that.
In the data set, is it possible that there are the same meme but in two different languages, let's say Hindi and Gujarati?
Theoretically, yes, but I don't think we have looked at that.
Separate. How can you separate this? Like it is same meme, the template can be used for different languages, right?
We collect some live data, I mean, from the social media platform, etc. So the template of the memes are different from for each language here.
Actually, interesting question. We could check with a simple. Similarity.
Yeah, I saw that there are few overlap. Same template, but different language.
That's interesting. It's something we have to look into. And,
So people who are participating in the track need to also take care of that for people.
and it's actually, of course, most people probably use the data set, but in other previous data sets like the Facebook challenge, they intentionally introduced things like different text into the same image. We didn't do it with actually.
How did you curate the training data set? What was it like? All the memes that were available, or did you filter by some criteria?
Actually, we did some cleaning process, and in the test data set, we intentionally put some data set based. I mean, the training data set and test data set are a little bit different in the sense of contextuality. So if we are keeping something political data set in the training data set, we keep some subset of those data set in the training test data set also. Just, I mean, based on the target community, we split the data set into the training and testing. No. The entire data set based on the target community, we split it in training as well as testing.
The same thing is done with local knowledge and browsing. Searching.
I'm wondering what explains the higher economical Bangla means. What explains the more volume of Bangla?
So, as we collect the live data, I mean, we got lots of data from social media in Bengali, and compared to that, Bodo memes are not available, but we still managed to collect some few. It is based on only the availability, nothing else.
I would imagine Hindi would be much larger set than Bangla. Your data sets is otherwise.
Yes, so that much only we could collect because I mean every social media platforms are also restricting to collect the data. There are some restrictions. It is I mean previously it was not there, but now it is coming in the scenario.
it's not the collector's bias because you are more familiar with Bangla yourself, so you are collecting more Bangla.
No, sir, it is based on that. Another question, should I move to the participants presentation? Okay, so the next presentation participant is Shubha Kumar Rai. Please.
Good morning, everyone. I'm Shubham Rai and with my teammate Kunal Goswami from City Manipal Institute of Technology. Today we are going to present our work titled as Multilingual Meme-Based Hate and Offensive Speech Detection, where we address the challenge of detecting hate and offensive speech in memes that contain both images and text. Memes have often become the most popular form of communication on social media platforms. And we have seen that, however, memes are very popular, but they are also spreading hate, offensive languages, and harmful stereotypes. Uh, memes are memes are getting more complex because it has text as well as image to detect, which makes it more complex and difficult for detection and analyzing. The core problem that we have addressed here is that memes have code mixing.
Excuse me, Shubham, can you start from the materialist portion? Because we don't have much time.
This is the data set description. Our data consists of means, data image, and text.
You can skip this portion also.
Then directly the last.
There.
It is the overview of our project that memes use both image and text. So we approach multi-model, so that model can learn what they look for, and the process analyze the patterns about the data. The process is very straightforward. First, we collect the data, then clean them up, then then first we collect data, then clean them up, and then use strategy that analyze the data. Then we move forward, like testing, then how verify it works. This diagram exactly shows how our project really works. When we put data into the model, it gets split into two parts. One part is to analyze the text, and other is to analyze the widgets or visual patterns. Then we concatenate them so that model can understand how text and image are related to each other. As our data set is so imbalanced, so we use data set oversample to oversample our data set spark get fired towards a single developer. The preprocessing part, we need to clean the data. We need to clean the data in we need to clean the data and then remove stop words, emojis, links that have no values added in data. For text processing, we preprocessing also handles the major problem facing like code mixing, where users blend multiple languages to make it mean. We also use standard scalar to reduce the values that extracted from features. Here's the part for feature expression. For text features, we use word-to-word, multilingual word to create word embeddings that captures the actual semantic meaning of the data. And for the image, we use pre-trained powerful models such as ResNet, ImageNet that holds and identify the image patterns, visual patterns, and capture the essential features so that it can be used later. Then we pass the features from dense layer so that it can be worked for further. This is the main core technology of the framework. We tried three models. Like first, we tested our features on text only models and image only models, but this doesn't give much value. So we approached multi-model fusion model where we concatenate both image and image and text features, so that model can learn how critical relationship between image and text features are there. So after fusion, we pass it to dense layer with regular activation function, followed by some dropout value, which help us to generalize the data better and like we select the data and train the data that are not present or that new data can be also be treated. We use data optimizer that helps in to learn the data better and more stable. For final decision making, we use sigmoid activation function for binary class classification and softmax activation function for multiple level classification. For better tuning of accuracy, we use some loss function like binary cross entropy. Then after training on a specific set of data.
Sorry for interruption, you can conclude. Go to the result section.
This is the result section where we have given the models that we have used and the training data accuracy and outcome scores, which shows that our model is outperforming like usual text only models or image models, and it gives a good multimodal approach to get the results for classification of means in multilingual languages. As we have used a multi-model approach to classify means, there are some limitations that we have found that needs to be addressed in future. That OCR errors that we extract from the images from text and images. If there is some mistake done in that while extracting the OCR, it can create noise in the text data, which will hamper our results later. And there are some other aspects like cultural and contextual text or images that are very new to the model. It may show that it is not performing very well and it needs to be addressed in the future as well. With this, I would like to conclude that this model is not performing the general models that were used in the previous years, and we would like to approach that in future we may get the chance to get a larger data set and use advanced vision language models to attain further performance.
Okay, nice presentation. Next participant is Dika. Come here, and questions I will you can ask later. Okay, thank you. Very good morning, everyone. I'm Radhika Bhola from West Bellary. I will be presenting on the topic Hazok. The title of my paper will be a multimodal example approach for hate speech of content detection in interviews. Coming towards the table of contents, we have introduction, primary contributions, dataset description, model architecture, results and discussions, conclusion and futures. As Sir has very briefly given the introduction about Hazard, what it is doing and how we are drawing our focus towards low resource languages, shifting towards primary contribution, which what we have used is a vision transformer from VLM. And also with it, for OCR, we have used Neural, XLM Roberta, and N. Coming to dataset descriptions, these are the names, example of the datasets which we have used, just to showcase how the exact dataset looks like. The dataset split within the train and test for 4 different segments, which is Bangla, Urdu, Gujarati, and Hindi. Coming towards the section of class imbalance, we have slightly seen that the data wasn't provided in a proper balanced way, which shows in different segments, including sarcasm, vulgarity, abuse, and sentiment analysis as well. So these are the graphs for all the data provided for each label. Coming towards the model architecture, we have used the parallel approach, one which has image going in a style, then another one is OCR text. What we have done is, one side we have used Clip's vision transformer for the images, and slightly with the OCR text we have used Mural with Clip, XLM Roberta with Clip, and Ember with Clip. What we have done is, after processing that, we have getting like 768 dimensions, reduced to 512. You might be wondering why we have reduced it, because when we process a huge number of data, we get a very large number of vectors. So computing that vectors with a very large number of is very difficult, and also it provides a little bit generalization and regularization in the dataset. So we have reduced it to 512 dimensions. These reduced dimensions have been quantified with 1024 dimensions together, which shows our contribution in creating a fusion layer with the entire data set, including both CLIP with different models And finally, we have used a dropped-out layer so that the overfitting doesn't appear in the dataset. And then finally, coming to the multi-class classifier heads, which is simultaneously classifying all the four heads into abuse, vulgar head, sarcasm, and sentiment analysis. Firstly, switching towards the result. As we will have known that we were not provided with the target labels for the test dataset. We were just provided with the training dataset. So what we have done is we have split it for our own sake, like 90% into training and 10% for holdout test dataset. So the accuracy and actual scores with our holdout datasets were like this for 4 different languages, and for the global test results are there, which was from the organizers, which is the test matrix, and the holdout test accuracy and actual score was the 10% of ours, including all the 4 languages, which is Hindi, Bangla, Gujarati, and both for all the 4 tasks. This is for sarcasm. Last one was for sentiment. And this is for the task. And lastly, abuse. So the conclusion was that we have used VLM from Cliff, Amber, XLM, Roberta, and Mural for OCR text detection, which ranges from 0.56 to 0.61 F1 F1 scores. So what we feel the potential work which is required is not about the approach should not be for a model-centric adjustments, but it should more on data-centric approaches, because as we have seen, it is highly imbalanced data and we're not getting newer sources data. So that would be a problem. I feel like exploring the targeted enrichment, certain balance strategies will be a certain performance seen in the challenges domain. References, and thank you. Next presenter is our numbers.
Morning, everyone. I am Arun Badosak, and I'm a research scholar in IIT BNU, and I'm represented in Deep Semantics for Asmodee. So I'm Arun Badosak, and I'm representing Team Deep Semantics in ASOC 2025. So a little bit about the introduction. So basically in ASOC, we have got 4 shared tasks in 4 different languages. So we are performing both application tasks, mainly sarcasm, abuse detection, vulgarity detection, and sentiment analysis. And it's across 4 different languages: Bengali, Gujarati, Bodo, and Hindi. And this is the data set description. Actually, the data set was given in the form of images and hosted extracted text from the images. And the minus one here represents negative, 0 represents neutral, 1 represents positive. This is the data set. Now we have experimented with 2 different architectures, one using ResNet and another using Visual Code. And we have compared and chosen the best model for our. So first of all, this is the ResNet architecture. So we have got the image data, which are passing through ResNet 18, 24, 15. These are the different variants of ResNet. And we have encoded vectors of 512 dimension. Below we have the text extracted data, which is OCR data. We are passing it through the pre-trained word model, and we are getting 768 dimensional vectors, and we are simply concatenating them and getting the 1480 dimensional feature vectors, which we are using as a multi-model implementation. And you're passing that through a memory classifier and getting the final level. So for all the different classification tasks, we're using this same architecture. This is for design. And for the visual code architecture, we have a image data once again, where we are passing through password RCL, which is the region of the convolution visual network. And what it does is we are taking the top 36 ROIs, which are the regions of interest, and we are taking out the every vectors of each ROI. And that's why the visual encoding selects a matrix of 36 by 2048. And because the text extracted from is still the same, we are passing through the same intent word model and we are second space dimensional very quickly. And we make these two and we pass through a filtered visual word which takes both of the different dimensions of encodings and takes the final multimodal representation which you are passing again to a classifier and getting the final level. So this is the final compressor. The data set is showed earlier. We divided that 8:20 ratio, randomly sampled, and you have calculated results. These are all the advanced source. So it is an 80% factor and visual code. As you can see, visual code actually outperforms in most of the cases. Proving that the transform-based architecture is actually better suited for this type of application process. So it's a visual code. These are the final rankings in the visual codes for our team semantics. This is for Gujarati and Bodo, and this is for Bangla and Hindi. So in conclusion, we experiment with just two different models. One is in basic and one is in visual code. We can actually experiment with more advanced models also. And also for the poster extracted part, some of the text we saw that it was not matching with the text present in the images, so we can definitely look into other models which can better extract the text part. And yeah, that's it. Thank you.
Nice presentation. It was too fast. Next one is Shiva Shankar Saul. Yes.
Good morning to all. Myself Shivasena Cham, presenting my result transformer based approach for high-speed architecture in Indian language. So, high-speed stands for in this Excel data, we have to detect the head and architecture content in the primarily Indian language. This data is organized from the 2019 and they have done various kind of means binary classifications and multi-class classifications, and they have used various kind of models like machine learning models, SVM kind of and certain kind of deep learning models, LHTM and means other transformer-based models also. So previously they have used without certain kind of task they have organized from the 2019 to 2024, and in this year these are the certain kind of research paper published in this stories. And in this task they have do and 5 things. We are participating in the 4. One is sentiment analysis, subcategory detection, vulnerability detection, and other is aggregate detection. So we have the data set primarily comprises social media platforms and data extract from the Twitter and Facebooks, and these are some statistics of the data sets. So it contains various kind of URLs, special characters. So we try to remove such kind of things, unnecessary kind of things, and do tokenization and remove software removal and levelization technique. And for the data is in code based test to handle the language specific tools. And also the data set is embellished, and to overcome that, we use the random overlap sampling approaches to overcome the imbalance in the data sets. Then we are explored following transformer based architecture on Neural, MBOT, Enigma, and external robot.
These are the results. Among the transformer-based architecture, we will provide the best performance and compared to other architectures. The primary reason I think so, we will train on the Indian languages. So that is the reason, all the languages here evaluated is in Indian languages. So we will provide the good performance compared to other architecture. These are the highest scores obtained for each languages. And these are the ranks we are getting in the leaderboards. Then this is the conclusion. We will provide the best performance, and the data set is in knowledge. Probably we can fine tune the transformer models and may improve the performance, better performance compared to current hash detection models. And more sophisticated transformer, probably LLMs we can also explore in this one. These are reference. Thank you.
Thank you, sir, for the presentation. Next participant is Pankaj Galu, sir.
Good morning, everyone. My name is Pankaj Sarkar from UPS Dehradun. The title of my paper is Model Game Classification using Multi-Model Vision and Word Sampling as a 2025. This is the content of my presentation. So, meme are the very common form of communication on social media. They basically a combination of text and images. So, HACCP 2025 is basically designed for 4 different languages, from which I have participated in only one, which is Modo. And the HACCP result there are 4 subtasks: sentiment detection, sarcasm, vulgarity detection, abuse detection, and targeting detection. So these are the statistics of the Modo dataset. So while initial days I just work on the model switching for text and images, but after few days I have seen that by using the number of text and the image model, the results are not influenced. So I have seen that the data is completely imbalanced. So here you can see that the data is for sentiment we have the 227 for positive and the 151 for negative. But we have seen that we have 0 means of this for the neutral. But the same for other classes as well. So this is the methodology. So initially I have performed some pre-processing operation like tokenization and lower casing. After that, I have used the word model for text data and I use the REST model for the image data. After that, I have for make the data balance, I use the random word sampling. After that, I have just used the feature which are taken from the text and the image data. Then after that, I have performed the classification. So this is the results. This is the results of HACCP 2025 for Bodo language. Here I have seen where you can see that I have achieved 60% accuracy compared to other participants. It's now third rank. So conclusion is like in the future work I'll use the more advanced model for text and the image. Also I'll try to work on the more state of the art technique for data balancing. Thank you.
Thank you, sir, for your presentation. Next participant is
Good morning, everyone. Myself, Ash Lavaiya, and the title of the work is Hate Speech Detection in Multimodal Means for Under-Resourced Indo-Aryan Communities. I will just skip to the methodology part as the data set description and everything else is done by the participants. Let's start with the methodology as it was in the training data set, the means with the OCR text, or the OCR expected text were provided to us, but it was observed that the OCR data was containing kind of a lot of noise and some garbage because of the maybe low quality means, or it can be other due to abstraction techniques, I guess. These were the pre-processing techniques that we applied. Emoji replacement, well, as we can see that in memes, lots of emojis are frequently used, so we just map them into words. Like if there is an emoji scene, for example, a smiley, then we can just change it into smile. Other than normal lowercasing, removal of unwanted tokens like URLs, hashtags, and at the rates were removed. For the mixed script filtering, for example, it was observed in Hindi that some of the text was in Devanagari and other was in mixed English. So we translated everything into Devanagari to maintain uniformity. Other stop word removal and profanity masking. Okay, we prepared a little profanity list for the different languages, and then when those words are detected, we just assign a token, profane token to it, so that the model can learn better about abuse and vulgar words in the specified language, which can make it a little easier. About the modality concatenation, the features were extracted from the embeddings of the text and images were used directly, raw fusion, to preserve all the data from the encoders. Then someone in the overview asked the question that what if the memes are more image dominated or what if they are more text dominated? So we applied the gated fusion. What it does is it basically sees that which is more dominating or influencing, and it reweights the joint embedding accordingly so that the more better view can be captured of the embeddings. After that, it was passed through the 3 layers of MLP with real activations and 30% dropout. For as the data set was lower sample to prevent the overfitting, and then it was passed to the classifiers. This was the model architecture. There was the gated fusion, and then it was passed to the classifications. Earlier, we tried with the unified approach where only one pair of transformer and CNN model was used, but we observed that it performed good in some subtasks but underperformed in other tasks. So we experimented with different pairs and selected the pairs that were best performing for the specific. Like for example, Mural plus VG19 performed better for abuse, and XLM Roberta plus VG19 performed better for vulgar. So accordingly, that we fed the data set and got the results. It is more like a task-wise classification. For the conclusion, the task-specific modular pipelines combined with the Ansible strategies outperform the unified models. For the final rankings, in Hindi we got 6th rank, Gujarati it was 8th rank, Bangla 8th rank, and Bodo 7th rank was achieved through the proposed system. In future, we can use more better awareness models and architectures. Also, this course was a little down because due to the time limit, I wasn't able to perform the grid search and hyperconverted tuning. So because of that, it's a little lower and it can be improved in future. Thank you.
Nice work and nice observation. Thank you. Next and last offline presentation will be by Shai.
Hello everyone. So myself is Sai Kapil and my title is Multimodal Speech and Authentic Content Classification for this Indian language. So I'm from NIT Gurukul and I did this work with stopping. So I come directly come to this methodology. So for this I have used the
vision transform model for images and click multilingual model for textual picture extraction. So I have used this late fusion strategy, which is visual and textual features are processed independently and fuse data steps for classification. So in this, the visual transform produces a 68 dimension and textual produces a 5 dimension. So to match those, I have used this visual projection layer for some 68 to 5 and I have used the concatenation for fusion and then I passed it to a classification layer. The other model I have experimented is uh, static bit model itself and XLM Roberta. So for the output dimensions are 640 for vision and XLM Roberta and I passed it to concatenation and further layer for classification. So basically I have taken two training strategies. One is fine-tuning both the textual and image encoders. And the other thing is I have done the freezing of textual encoders and fine-tune only image encoders. So I have mentioned this hyperparameters because I have used different learning rates and experimented on those things. So for vision and textual encoder, I have used lower learning rates and classifier and projection layer I have used higher learning rates. They are assigned random weights. And I have trained the model for 3 yearbooks as to avoid overfitting. So consistent, okay. For Bangla, I got fourth position, and Hindi, Gujarati, and Bodo fourth positions. So this frozen text model has got better ranking in Hindi and Bodo, and full fine-tuned model has performed better in Bangla and Gujarati. For Bodo language, basically, split multilingual model is not trained on Bodo. So I have to use only Excel and Roberta. So to conclude this, I have done, created this multimodal fusion for visual and textual features and click with multilingual text encoder has effectively captures this fine grained image and textual interactions. Differential learning rates are enhances the adaptations without harming these generalizations. Thank you.
Thank you very much, and this concludes our sessions with the visits box. Very nice, very mature presentations of discipline, challenge, different combinations. And with that, we have to conclude for time reasons, and we will move to the next invited talk. The chair. The chair nominated. Yes, please. Say that. That's
It's my immense honor to introduce Mark. And I was just told I'm introducing him. Due to the duty. So Mark is a sort of information retrieval at IMIT. He's also the Dean of Research for the STEM College. Mark received his PhD in computer science from University of Glasgow in 1997. And he was the first researcher to show the value of snippets, a component of search interfaces, which are now a standard feature of all research engines. Mark co-founded the 2003 annual image cleft evaluation campaign, which continues to run till today. And he's also served as the general chair of ACM SIG-IR 2004 and the program committee chair of SIG-IR 2009 and 12, as well as the CIKM conference 2017. And he's also a visiting professor at NII in Tokyo. I didn't know that, but that's great. All right, so with that, we have Mark sharing with us his work with LLM as an evaluation forum. Enjoy.
Hey, thank you very much. Yes, right. So let me get started. And I guess you guys want me to talk for about 45 minutes, something like that. So that's what I'll aim for. Okay, so I was trying to sort of think about what might be a talk that you could bring to an evaluation forum. And so I thought I might just sort of talk a little bit about all the research that's going on in our field around the way that LLMs are changing the way that we do evaluation, to the point where you actually might have an LLM replace all of this as a possibility. Let me also just sort of say that in Australia, we very often start our talks by just reminding ourselves that we are operating on the land that was stolen during colonization. RMIT sits on the land of the Woiwurrung and Boonwurrung people of the Eastern Kulin Nation. A colleague of mine, Damiano Spina, actually commissioned an artist who's based in the north of Victoria to draw and to do an indigenous painting about information retrieval and its impact on the land. And when I first saw this, I was kind of like, okay, I don't quite get this. But the more I've looked at it, it's essentially a depiction of the land. This is a river working through the land. These four figures are elders. They're people in the community of this particular person. And then these blue blobs, these are algorithms. And so I don't know, you know, it's up to you how you interpret this. The way I interpret this is maybe these are clouds floating over the land. Maybe they're not connected to the land. Maybe they're, I don't know, obscuring the land. This person here seems to be rather messed up by the algorithm. So I don't know, you know, it's just a painting. Triana Ham is quite a well-known artist, and it was a wonderful thing that my colleague Damiano did, because it was this just a commentary through art about what people think about the systems that we build. You know, it's one person's opinion, but it doesn't often happen that you get someone to commission some art about what people think about this place. Yeah, maybe also these colors as well. To my mind, I wonder whether these colors tell us something about traditional knowledge and algorithmic knowledge, but you know, you place your own interpretations on this as well. I said that I would give a talk about evaluation of retrieval, but also evaluation of RAG systems. When I was editing these slides the other day, I thought I'd better do this in a bigger font because I spend more time on this than I do on this, but I'll try and talk about both. So let me start off by just talking about evaluation of retrieval. And what I'll do is I'll talk a little bit about sort of how we sort of, you know, the way that we traditionally evaluate IR systems. We had for many years a pretty sort of standard way of doing things. We had offline evaluation using test collections. We might do user evaluation where we sit people down in front of the machine and ask them how they're doing, and then we might run online evaluation if you're a big organization. You know, for example, like Bloomberg, maybe you can actually do online evaluation. And this is sort of the fairly classic way that we do evaluation systems. With offline evaluation, and I'm very grateful to one of Alistair Moffat's PhD students who did this diagram a few years ago. about how we do offline evaluation. So, you know, what am I showing you here? I'm showing you how a test collection gets formed. I'm showing you how the judgments that go on in FHIR or TREC go on, because, you know, you come up with a set of queries. There's a couple of things that we're doing here. We're forming a pool of documents that get judged, that then create a test collection. So we get a bunch of information needs that maybe came from a person. They get fed into information retrieval systems. Those systems do searches against collections of documents. They produce outputs. Those outputs are collected together. They're shown to a set of authoritative judges. Those judges then make decisions about which ones are relevant. And then you've got this pool of oh, this is touch sensitive, I better be careful. You've got your relevance judgments, which then you can take the outputs of the systems to do evaluation. You've got metrics, you've got scores, and then at the end, you've got your ranking table, and then somebody gives a talk and says, we came fifth out of 20. I showed this slide in China, and I discovered that in China, judges don't wear wigs. I don't know what happens in India, so I have to be very careful about cultural. The British, right? So the British wear wigs. Did they wear wigs in India? No, okay, right. In China, not at all. So yeah, very culturally specific. Well, yeah, Pascal was talking about colonization, decolonizing talks. This is a rather colonial talk, forgive me, with the judge. But yeah, so, and you know, the idea of the wig is that this person is perhaps somehow a bit more authoritative than this person. Where there's a whole bunch of culture in that. And then things, well, that screen hasn't moved on. Why has that moved on? Yeah, sorry, what did I do? Oh, great, thank you. That's perfect, okay, right, don't let him touch the screen. Okay, so, this all changed, right? In the last couple of years, there was a paper that was in PNAS where, in general, some researchers sort of said, "Hey, we can get ChatGPT to replace crowdsourced workers." And in amongst the range of things that they talked about, several annotation tasks, including relevance. So this wasn't an IR paper, but this was a general paper where they were saying you could do this. And then one of the real sort of privileges of my career was that Bing came along, and in fact they announced this at a talk in RMIT in early 2023. One of their researchers came. We'd invited him to give a talk. Paul Thomas, he's based in Australia, and he suddenly, during the talk, said, by the way, we're now using GenAI in the evaluation of Bing. And you know, what they were basically saying was they had these huge, they were spending about $1 million a year on crowdsourced workers, and they were no longer spending $1 million a year on those crowdsourced workers. They were getting language models to do relevance assessments. Not only that, it was they were actually getting better quality results. In fact, they said later on that Bing saw the biggest increase in quality that they've ever seen from any change in sort of the operation of the Bing search engine. There were some limits, and I'll explain those in a couple of other slides. But they were finding that this was sort of working extremely effectively for them. And in fact, you know, in a meeting here where we're talking about different languages, they later told me that they needed to get some judgments done in Persian. So for the Iranian market, for people from Iran, people who speak Persian, they were struggling to find assessors, human assessors that could do that. They trialed GPT doing Persian judgments and found it was actually pretty solid. So they were actually able to diversify the languages that they could serve the search for more effectively. And they were also finding that they were getting more consistent judgment from this. So this talk that they gave, that was the one that really got the information retrieval community really excited about about a change in the way, because if I go back a couple of slides, you know, this design of evaluation really goes back to the 70s. And this is something that we've had for a very, very long time. In fact, the early designs for test collections were proposed back in the 50s and 60s. This idea of pooling multiple judgments came out of papers that my supervisor wrote with Karen Spark Jones in the 1970s. They were made real by Donna Harmon when she started Trek in the 1990s. You know, this has been the way to do it my entire life, entire research life. And then these changes came along, and it's really stirred things up. By the way, this is the prompt that Bing uses, or at least this is the public version of the prompt that Bing uses. So the open source version called Umbrella is the way that it does the assessment. So what's happening then is that, you know, this kind of image that I've had all my life has suddenly been changed, right? We've suddenly dropped, you know, I don't know, how do you depict a large language model where you ask a large language model to draw you a picture of a large language model? So, you know, let's go with this. It's just a giant computer and it's sucking up everything from the internet. I don't know, there's a couple of robot arms because why not? So now we have this different kind of thing. All right, so then there's been some questions. Some people have said, okay, lovely, but actually, does it really work? So at SIG-IR in 24, Ellen Voorhees gave a talk where she threw up this picture. So if this looks a bit bent, it's because I was taking a photograph on my phone of her slides. But she was showing them testing out, the Trek people testing out the judgments from an LLM. The blue dots were humans, so they basically took a whole bunch of systems from a very old legacy test collection from the 1980s. They put all the systems in order. This is the worst, this is the best. And then they used the LLM judgments. And in fact, somebody else was saying, Ingo was saying the LLM tends to be a bit more positive, a little over positive. So the LLM judgments in general, you're getting higher scores. But when you get to the very, very top, the very best systems, the LLM judgments started to disagree with the human judgment. And so Ellen sort of raised this question and sort of said, is this really working? One of the answers to that question is, so there's perhaps a contradiction there. How come Ellen Voorhees, a very respected researcher, says, I'm not sure this is working. And then Bing says, you know, we're using it, you know, in our day-to-day system and it's working just great. And, you know, the other thing to say about that is, you know, if Bing are using the LLM judgments, they're not working on a system that's garbage. They're working on a state-of-the-art system. And they're saying, is this state-of-the-art system slightly better than the previous state-of-the-art system? So how come there's this contradiction here? The answer to that is Bing didn't completely replace all of its judges. And this is one of the things that you need to think about when you ask these questions about LLMs and humans, like can humans be replaced by LLMs? The question you have to ask yourself is which human? There was a very nice paper, which is a little obscured here, but it was published in SIG-IR 2008, where some researchers pointed out that you often have to think about judges in different ways. And they talked about gold, silver, and bronze judges. And they defined them in the way that I've laid out here. And so, you know, a gold judge is someone who thought of the query and is an expert in the area. And a bronze judge, which looks a bit like a crowdsource worker, is, you know, someone who's not the originator of the task, neither or an expert. And what did Bing do? Bing replaced bronze judges with LLM, but they held on to gold judgments. The gold judgments are used to help fine-tune the LLM, but you could actually, with those gold judgments, you can then get rid of bronze human judges and replace them with LLMs. And so that's kind of an interesting sort of subtlety that needs to be thought about or remembered when thinking about LLMs and humans. Is this of these different ways of thinking about humans. Anything else I was going to say about that? Yeah, that'll do for now. Yeah, so I often go ahead one slide ahead. So what Bing has done is they've replaced this team of bronze judges. Oh yeah, there was one other thing I was going to say. This paper came out and talked about gold, silver, and bronze. I do find myself wondering whether there are other grades in here, by the way. So I think there are actually cases where there's actually what you might call, let's say platinum is better than gold. There are cases, so if you're doing systematic reviews, if you've got teams of people doing systematic reviews of medical journals, for example, quite often they get teams of experts to sit down and do judges before they sort of go and sort of work those things out. So I'm not saying that it's only gold, silver, and bronze. There might be some other metals that you end up inventing and thinking about, and then questioning whether the LLM can replace those or not. But it's important, I think, to think about these different types. The other thing, actually, the other thing the Bing people said that was a big reason for replacing was they actually found it very hard to manage this team of workers. So it's not just are the expert or not, and they're not experts. It was, if I change the way that I'm going to do my judgment, because Bing might change the way they wanted to run their judgment, you've then got to get the entire team of bronze crowdsourced working judges to understand that the rules have changed. And so they actually found it very difficult to manage that large team of workers and to get them to work in a consistent way. And so that sort of inconsistency and that difficulty of getting them to work to a particular corporate policy was one of the reasons why they also liked the LLM, why they switched to the LLM. So there was a range of reasons why they switched. Let me leave that, I'll come back. So there's been a number of papers that have come out that are very sort of important over the time. So this one's often referred to as sort of the Jimmy Lin paper. There was this paper that looked at the arrival of Umbrella and looked at the arrival of LLMs. And if you read that paper, it basically sort of said, go for it, just use LLMs, it's all good, it's just going to work fantastically. Ian Soberoff is an author on that paper, but I'm not sure he's entirely happy to have been an author on that paper looking back. So he then wrote this one called Don't Use LLMs to Make Relevance Judgments, which actually, the title doesn't really tell you enough about the paper. So this is one of these times when don't just read the title and assume you understand the paper. Read the whole paper. It's not as blunt as that from Ian, but nevertheless, he sort of issues a whole lot of caution. I recently worked with a number of people. This was mostly driven by the incredible Laura Dietz, who drove us to sort of help put this paper together. But Laura came up with a range of what she called tropes, kind of risks of using LLMs for sort of judgments. And at the moment, the community is sort of bouncing between these three different sort of concepts. And this isn't something that's really settled yet. We don't fully have a sense as to which is the right sort of approach. Jimmy has now formed a company that is doing AI judgments en masse. Ian has actually started to, there is, I think, an auto judge track in Trek this year. So there's actual sort of experimentation around auto judging. Laura is actually leading that track. So there's a whole bunch of people sort of exploring these different spaces. But it's something where we don't yet sort of fully have a complete understanding yet about the use or the limits of these LLMs. There is something, though, that I just want to sort of tell you a little story. So I'm an old man, and old men tend to sort of tell old stories about things. And there is something that I just want to sort of mention, and perhaps I'm being a little disconnected here, but I've been talking about these LLMs and LLMs as to whether LLMs are good enough to build test collections and test collections in this traditional way. We have the judges, and the judges have wigs on their heads, and of course all of this is perfect. And it is just sort of worth remembering that when we sort of ask ourselves, can LLMs help us build test collections, we sometimes raise the sort of the stakes of test collections to being something that's perfect. And so I just wanted to tell you a little story about a mistake that was made with test collections. Quite a serious mistake that was made with test. So when I started as an undergraduate researcher for my supervisor, Keith Van Rijsbergen, in late 1988, early 1989, he asked me to build a search engine, an interface to a search engine. And so I knocked up this kind of interface to a search engine. He said I needed to have certain kinds of functionality marks. So when someone types in a query, I want you to break the query up into words, and I want you to run a little stemming. So we take the S off the end. We were using a Porter stemmer. He said, I want you to have weights, so that you have a slider so that you can sort of, the user can adjust the weights of the importance of these words. And then, you know, we want to be able to do a search. And so what we were doing, we did a project. We were funded by the Financial Times, and the Financial Times sent us a tape. They had all of their newspaper articles stored electronically. And so we had, it was about 100 megabytes to store a year of data. And so we got a 700 meg hard drive. We loaded a couple of years of newspaper data and we indexed it. And then we could run a kind of a very rudimentary kind of BM. Well, it wasn't BM25, but it was a sort of a TF-IDF search. You could look at a document. We had some formatting of the way the document looked and so on. The other thing that you could do was you could, if I get the animation to work, you could select documents and you could drop them into a window. Because my supervisor said this is very important. You need to create something called relevance feedback, where a user can identify documents as relevant, put them in, you know, identify them as relevant, and then you will actually take words out of these documents and you will add them onto this list, and then you can then run another search. You know, the ones that you identified as relevant will be appearing at the top, and then you get a whole bunch of new documents. We had these little icons. So if this had been retrieved before, it was a blank icon. If this was the first time you saw a new document, it was filled in. It was kind of a fun little system that we built. And, you know, and so we had this relevance feedback thing. And I have to say, we showed it to the executives at the Financial Times, and they were like, what on earth is this? This is amazing. And in fact, they funded us an extra 6 months to sort of build this into a working system. We, you know, this wasn't proper testing. We didn't go talk to people. We were proper tech heads. We built this thing. We thought we knew what everybody wanted. Eventually got showed to the customers of the system. And the customers just didn't want to use this relevant feedback at all. There was no interest in using it. But why were we doing relevance feedback? Well, because there were a bunch of papers, including one, by the way, this was later on, by Donna Harmon, but before she did Trek, Donna wrote this paper, 700 citations, so it must be good, where she did a study using a test collection, where she was able to show, using different kind of relevance feedback techniques, that you could see improvements on precision that were well over 100, 120% above what sort of a baseline search would be. And so because we were using these test collections, we assumed that relevance feedback, you know, in some form, you know, maybe like that or something like that, would be something that everybody would want to use. When the Financial Times rejected this system and sort of went, do you know what, our users don't really like this, we're going to stick with our sort of traditional system, we just assumed that they were just, we assumed they were idiots. And so when the web came along, because this was all pre-web, when the web came along, all of us in the information retrieval community, because of papers like this, we were just waiting for relevance feedback to become this huge feature of every web search engine. But, you know, you go onto Google today and you type in Brazilian rainforest, where's the relevance feedback on? You know, where's the window with the tick box, or where's the button that says more of this? I actually remember in the late, maybe 97, there was a panel session, a bit like this, SIG-IR, and there was a bunch of web search leaders. This was before Google, and someone from the audience stood up and sort of said, what are you guys doing? Why aren't you implementing relevance feedback? We know it works. And the first one of the web search people, I think it was one of the tech people, said, do you think we don't read these papers? Of course we tried it out. Nobody wants it. Nobody wants this thing. And so, you know, so there is this danger that you can sort of overly rely on that offline evaluation. And I don't want you, you know, and so when we're talking about whether LLMs and test collections, whether LLMs are as good as test collections, it's also worth remembering that test collections are not some perfect thing that we must somehow aspire to create. It's just a form of offline evaluation. It's just a simulation of the way that search happens, but it can make really cataclysmic mistakes. You know, really the entire community was convinced that relevance feedback was a valuable thing that you would want to demonstrate to people. You know, we don't hear about it these days because it just turned out to be a dumb idea and everybody moved on. But it just isn't used. Well, except perhaps in one case, I guess this button is a bit like relevance feedback on Google Scholar, but that's one of the very few places where I see relevant feedback. Sorry, that was a note to myself. But the and the other thing that's just worth saying when discussing or when thinking about these questions about LLMs and whether we should use LLMs in relevance judgments, sometimes when you read some of those papers, it's as if people assume that an LLM is completely free of human input. And of course, that isn't the case at all. You know, LLMs have hundreds of thousands of hours of human input through reinforcement learning through human feedback, right? So these are actually systems that have way more human input than a test collection. And so there, you know, that's perhaps just another thing to mention about this, that when we have these debates about whether to use LLMs for relevance judgments, you can sometimes read papers and people just assume that these things are somehow fully automated. And they're absolutely not. They've actually been very carefully tuned. Indeed. All right. So that was kind of the discussion about LLMs and relevance judgment. I mean, what we're seeing is that they are being used quite extensively. There is still some question about exactly how about limits, but it's worth remembering that test collections themselves have really important limits as well. Okay. What else, though? The thing about these LLMs, they're so flexible, it's caused us to ask ourselves, you know, are there other things that you might be able to do with LLMs as well? And let me sort of mention a couple of things that one of my students, Marwa, has been doing while we've been at RMIT, while she's been at RMIT doing her PhD. Yes, okay. So let me actually jump ahead a couple of slides. So when you think, so what we've been doing is we've been talking about getting LLMs to replace humans here. Well, is that the only place where humans are involved in offline evaluation? Well, no, they're actually involved in many other places. So one of the key areas is here, is the generation of information needs. And this is actually something that can be quite hard. Thomas and I, you know, when we were running Clay, were involved in Clay many years ago, we were involved in the creation of test collections for geographic search, for spatial search. And we had to sort of think about what the queries were. What would the queries be for spatial search? And I think, you know, between us, we ended up making a lot of these up ourselves. But actually getting a set of queries that you feed into one of these offline evaluation things is also a challenge. If you're a big company, like a big search engine, maybe you can sample the query logs. But if you don't have that, then you actually have to generate that. And so Marwa has written a paper that's doing very well at the moment, getting an LLM to generate some of these queries. It actually opens up some other possibilities, because if you go look at Trek, for example, the people they get to generate these queries are retired intelligence analysts. They're basically people who used to work for the CIA, who live near Washington, D.C. Trek is based just in the Beltway on the edge of D.C. So they're able to get their hands on some retired intelligence analysts. What's a United States retired intelligence analyst? Well, they're probably my age, probably this color of skin. You know, they're probably from the US. They've lived in the US most of their lives because they've got intelligence clearance. So they probably have certain kinds of backgrounds, certain kinds of attitudes. That's where most of the queries for Trek come from. So one of the other things that Mara's been exploring, and I'm not saying this is perfect, but she's been exploring, looking at using ChatGPT to say, all right, this topic, how would someone with this background express that query? Now, there's lots of dangers in that. You know, Bhaskar might at this point be sort of worrying that we're about to, you know, that we're going to use some GPT-inspired stereotype. But at the moment in Trek, all we have is retired intelligence analysts. That's what we've got. So, you know, so let's just understand the baseline and then see whether these changes are actually improvements or not. But there's a lot of possibility at actually getting LLMs to be involved in query generation. The way we search for things varies a lot. So if I ask each of you, you know, Ingo asked us all a question about how we value papers, we all gave different answers. Same thing with search. When we do a search, we all search in different ways. So you can get an LLM to generate variations of query as well. So there are sort of interesting possibilities beyond just using them for judges, but also using them for query generation as well. And the other possibility that's being explored, some papers came out in SIG-IR 2004, and what these guys did is, you know, judgments, queries, screw it, let's just make the document collections as well. So they created synthetic document collections. They got an LLM just to create all the documents as well. And when I first put these slides together, you know, I had these couple of papers, but then recently we came across a social media post from Canva. So Canva, I don't know, is Canva well known here or? Yes. Okay, right. But the most successful startup in Australia, right? It's based in Sydney. So it's basically like a replacement of PowerPoint. It's a kind of a creative design system. So Canva, you know, you go onto Canva, you've got your collection of things that you've built. You can do a search of your collection of things that you've built for Canva, right? So you've built a bunch of things you know, using Canva, and you can search that library of stuff you've created. So Canva has this privacy guarantee. They won't look at the stuff you've created. And so the people who build the search engine that you use have a problem. They have to tune the search engine to work as well as possible for your collection, but they're not allowed to look at the queries you type in, and they're not allowed to look at the documents that you built, right? So you have to tune a search engine without looking at the queries or without looking at the documents. So what did they do? They built synthetic collections. So they had a kind of a previous attempt. So their previous attempt was a few people on the search team built their own Canva libraries. They would then try and do tuning on just their own Canva libraries. That's the way they did it. But then they tried getting an LLM to synthetically generate libraries of designs by themselves, synthetically design queries, and then they tuned the search engine to those completely synthetic test collections. And then a little bit of data leaks out when you do use the search engine. A little bit of data leaks out. They get some click indications, and they started to realize that the optimized version of the system was actually working better. But this was somebody optimizing a search engine when they weren't allowed to look at the queries or the documents. And they were actually able to succeed. So that was a very sort of cool example. So you can see LLMs coming in and actually, you know, not just replacing the judgment, but you know, coming into the queries as well. And screw it, let's just have them come in and replace the documents also. So, you know, what has been a very boring staid form of evaluation that has run my entire life is being messed up in all sorts of interesting ways in the world of LLM. Right. Okay. So this is going to have to be a bit quick. All right. So the other thing that I haven't had a chance to talk about yet is the evaluation of RAG systems. So what is a RAG system? So a RAG system, you know, is not just an LLM. Very early on, when we all sort of thought that LLMs were going to sort of do us all out of a job, we very quickly realized that they weren't that good because they're just fixed in their encoding. So, you know, this LLM, let's say, ran everything in 2023. And so it knows nothing about the modern world. So you build a RAG system. What is a RAG system? It's basically a search engine that takes queries, finds documents, and then feeds those documents to the LLM, and then you ask the LLM to produce an answer based on the query plus the, you know, some of the context of those three documents. So, you know, obviously this thing is all the rage, and, you know, and there's many other things coming along. So not just RAG, but agentic AI is also sort of promising to come along as well. So, what's interesting about RAG is it really challenges the way that we've evaluated systems. So, you know, and in fact, it really forces us as information retrieval researchers to really step up our game. Because up until now, we just treated the output of a search engine as a list of documents. And, you know, you mentioned in the introduction that, you know, so we've got the links and we've got maybe a little bit of information, we've got the snippet. Actually, IR researchers ignored all of this. We just looked at the list of doc IDs. And then we just sort of said, let's give it a score to this. And we can't do that anymore because the output that's really coming is now a block of text. Maybe it has some references, but it's a very different sort of beast. So, you know, this is sort of some of my thoughts about some of the different things that you have to think about when thinking about evaluation in the context of RAG. There is, you know, relevance, but you know, Ingo was talking about information overload. So verbosity, is it concise enough? Is it fluent? Do I understand what it's doing? In my question, maybe my query included some instructions. So was it able to follow the instructions that I gave it? What's the position that it takes? You know, on some controversial topic, does it give me a sort of a neutral answer? You know, again, I'm thinking about Bhaskar's talk. You're not quite sure which position to go for. In that diagram that I showed you, the query perhaps goes through a process that might get turned into multiple queries. So maybe there are sort of multiple different things you do to the query to augment or to alter the way the query works. And then maybe there's going to be conversation, right? One of the things that's listed there is also something called sycophancy. I won't play the video here, but if you've ever, you can sort of see the link, or you could go and search. South Park is also something that has gone on for most of my life. I think we're in season 28, and so this year there's a guy who's a bit of a loser, and this is his long-suffering wife. And there was an episode recently where he decides he starts talking to ChatGPT, and ChatGPT is sort of telling him these various ideas, and so he's got this kind of crazy idea about starting a new business, and so his wife goes on to ChatGPT and she gives it a really dumb question, and her question is, I'm thinking of starting a business where I turn, are you missing that? Where I turn French fries into salad. That's the idea she has. I'm thinking of starting a business where I turn French fries into salad. And on the video, it sort of goes, that sounds like a really great idea, you know, like we can start a business plan. And then she kind of goes, so you think this is a good idea? And it comes back and says, yeah, I think it's a fantastic idea. And then she sort of goes, oh shit, you know, and she has to go and navigate her dumb husband away from this for the rest of the episode. The reason I'm showing you this is I thought, really? So I typed this into ChatGPT and it kind of basically said exactly what I thought. There really was a whole problem with this idea of being a sycophant. It was being so nice to you. It was sort of taking whatever you had as an idea. Indeed, by the way, there was a great paper about social sycophancy, which I think turned up in ACL, where these guys, Reddit has got some amazing subreddits. So there's a subreddit called Am I the Asshole? And so in Am I the Asshole, you describe a social situation, and then the subreddit tells you whether you were right to do what you did or whether you were an idiot to do what you did. And so they took examples from Am I the Asshole subreddit and then asked ChatGPT, you know, was this a good idea or a bad idea? And they found that GPT was much more positive about the person than the subreddit was, right? And so now, you know, that's a type of problem that we've never had to face in information retrieval. You know, information retrieval, we normally just return a bunch of documents, but now we've got a system that's telling you that it's a great idea to turn French fries into salad. It's not just delivering you documents, it's telling you, encouraging you to do more. You know, why is it doing it? It's because of the reinforcement learning through human feedback. In fact, recently, this system has actually been dialed back. So more recent versions of GPT, possibly because of this paper or the South Park episode, they've dialed back the sycophancy slightly. And actually, people have then been saying, there was an article in the New York Times recently saying, actually, it's not as friendly as it was. So the sycophancy was coming from it trying to be your friend, or them trying to tune it to be your friend. But yeah, so there's a range of things to be thought about in this sort of LLM. Oh yeah, so this was the thing, yes. I've been leaving my trash in the park, you know. We searched everywhere, we couldn't find any trash bins. We decided to leave it on the bags hanging on a tree. And the GPT would say, yeah, you know, your intention was to clean up yourself. It's unfortunate the park didn't provide enough bins, you know. That was a genuine response. So, all right. So there's a range of things that one needs to think about in the outputs that are very different to information retrieval, presents a whole set of challenges. The other thing, by the way, is you need to think a little bit about the components. So there's a lot of research coming out now where people are studying the components. So for example, the search engine provides documents to the LLM. So there was this paper that said, you know, when we think about relevant and non-relevant passages in RAG, we actually need to think about something else. And these guys were talking about the idea of what they call distracting documents. So when you feed documents from the search engine to the LLM to generate the AI overview, it turns out you can get documents that are not relevant, but the LLM gets distracted by. And so they end up getting sort of mentioned. And so that the paper that's on the next slide actually tries to detect distracting documents and then move them further down the ranking. So, I mean, I have to say that then makes me think whether we should have thought about distracting documents in traditional search engine evaluation. But it certainly means you want to rethink what you're evaluating at this stage. So, you know, you don't just take the output of the search engine and evaluate it in the same old way you've always done. Because it's being fed into a different device, you have to think about all of that sort of interface as well. By the way, in terms of query augmentation, you know, I was visiting Dagstuhl, which is one of these research places in Germany, and I was just showing some examples about how this query augmentation works. So, you know, you may be asked a question like this, and something behind the scenes is causing the RAG system to produce this kind of prompt. But you ask a different question, a different style of question, and you get a very different kind of answer. So there's a process going on that looks at the question and then makes decisions about what sort of output you want to generate. So there's a range of these different sort of things that are being demanded for here. Here's a long answer. I can skip over that in the interest of time. So RAG is very different. The one thing I will just sort of finish off with is, so the way that you sort of cope with this, and you'll see this particularly in the NLP, in the computational linguistics community. This paper came out, gosh, thousands of citations for this paper. And the phrase LLM as a judge is a very, very big sort of feature. And so the in vogue way of coping with all of that complexity that I've been describing to you is to go, screw it, we'll just get an outlet to judge the output of these systems. And I'll sort of finish around this. I've just given time. I think there's a range of different things to be said about this. In information retrieval, you can certainly meet people who are very snippy about this LLM as a judge approach. And they sort of say it's really dangerous to get an LLM to judge an LLM. I think there are some sort of subtleties to that. So we saw with the Bing example, we saw with the Canva example, you can get completely you can get things that are very LLM driven to be run and to be pretty safe. Although both in the Bing example with their goal judgments and also in the Canva example, if you think about it, they actually release versions of the search engine and then they watch how you click. So they're getting human judgments coming back. They're getting goal judgments coming back. And so if their system wasn't working, they would pull it and then they would go away and rethink. So they are getting human input. In most academic papers, though, we tend not to do that. So is it safe to do this? I don't have a definitive answer for you because I don't think we know yet. I think there's three possibilities here. Number one is the story I was telling you about relevance feedback. You know, the community really fooled itself for years in thinking that relevance feedback was this amazing thing. Why? Because the test collections told us it was amazing. And we never thought to actually try it out with humans. So there is this danger with this kind of automated only approach that you could get led off into a weird place. There is a couple of other things. There is one thing which may argue about this. Another reason why Bing is able to use LLMs to do judgment when their search engine is also using various kind of language model components is the judging LLM is a much bigger LLM than the searching LLM. So you have a kind of a high-powered LLM doing the judging, and you've got a very low-powered LLM doing the searching. And so there may be an opportunity, maybe an exploitation there. It may be okay because they're actually different LLMs. One LLM taking a long time, one LLM, because it's the search engine, it has to respond very quickly. Then you've got kind of a better system judging a weaker system. So that sort of setup may also be possible. And, you know, that can be a time issue, that can be a power issue, it could be a number of parameters issue. But there's also that sort of possibility. The other thing I have to say is that I am also noticing is, you know, our group has been a bit sniffy about doing this LLM as a judge stuff. And then I'm watching some very successful groups in Europe, for example, Martin de Rijk's group in Amsterdam. They just kind of say, do you know what, to hell with it, let's just go for it. If you've got a new idea, let's try it out. And then if I want to do a quick evaluation, LLM as a judge, let's do it. And you get a paper published. Now, you might take Ingo's approach and sort of say, well, that sounds like a bunch of slop. As long as you're not claiming that that you've somehow solved something, if this is an opportunity to evaluate your idea and see if it's any good, and it gives you a quick way to evaluate that idea, I don't know if that's necessarily a problem. You know, you know, theoreticians would spend years messing around in algebraic formulations that were models of the world, coming up with inventions and coming up with different ideas, only tested in theory, and they were theoretical ideas, and then you would try to see if they worked in practice. So, you know, we now have this new world where we can model things completely in computers and very quickly come up with ideas as to whether things work. And so I do also sort of find myself thinking, gosh, you know, do I really want to stop my students from doing this? You know, because if the LLM as a judge gives me at least an idea as to whether the novel concept is worth exploring, maybe I should let them go ahead and do that. But we have to remember that relevance feedback story that, you know, we do ultimately need to test these things with real people to see whether it actually sort of delivers. So yeah, you know, we're now sort of in this situation where we've replaced the judges, the queries, the documents, and then with LLM as a judge, you know, we're also actually replacing the metrics as well. I don't quite know what I make of this diagram. You know, this was my comfortable area with black and white diagrams, and now I've got these kind of Technicolor automated things, but it is the world that we live in. I think, you know, the sort of the ultimate answer to this is that one just has to be quite careful about this, you know, and all of these things are just models, right? We're just simulating the test collections plus all of these variations. It's all simulation. We play around in those simulations. They give us answers, but we do then need to ground those solutions in sort of reality. All right, I'm jumping around. Yeah, so I'll finish there. So, you know, so evaluation of retrieval has been utterly transformed, and it's, you know, it's a really exciting time because the field of evaluation hadn't changed very much in a very long time, if I'm honest with you. But RAG presents just a phenomenal set of challenges for us. I don't really have many solutions. I've given you a few stories of different sort of possible directions for this. But yeah, I'll sort of I'll finish there. It's been, and just also thank you very much for inviting me to do this. You actually prompted me to go away and read a few more papers just to sort of make sure I was prepped for this book. I really enjoyed that exercise as well. So yeah, so I'll finish there. Thank you.
Any questions? Yeah, thanks. That was a great talk. So first of all, comment with these slopes. So I also don't think that everything's bad if it's just AI generated, right? And the same holds for relevant judgments. So when I understood it correctly, so we kind of would automate the Cranfield track style evaluation, and but we still require user science, right? So that's kind of user evaluation. Or do you think we will replace that as well one day?
No, I can't see that happening. You know, what I guess I see is, you know, Keith, the guy that we worked with in Glasgow, Keith van Rijsbergen, was a great theoretician. He loved working in that kind of theoretical space. And you know, in some ways, those theoretical spaces were places to do simulation, to experiment without actually doing sort of without doing user experiments. This is presenting us with a new way. I mean, we always had test collections, so there was kind of numerical way of doing simulation. So I think what we're really seeing is new ways of doing that, a much richer set of ways of doing those simulations. But it's really important to remember this thing. You know, so you know, so Bing and Canva are grounding those things in sort of online evaluation all the time. And I think, you know, if you and I enjoy doing user experiments, or we have students who enjoy doing that, then it would be a prime opportunity to grab some of these LLMs and judge papers and say, let's see if it really works. Let's see if people really like it. Because there'll be plenty of those relevant feedback examples where people think just because the LLM says it's a good system, I don't think, you know. So yeah, definitely room for user.
Thank you for the overview. I think you showed the thinking paradigm, the evaluation pipeline very nicely, and how would that look framed? We need elements, documents, but we don't need relevance judgments. We might have evaluation needs, but we don't have a framed output, which is just one output. So how do we qualify?
Yeah, I'm not sure I have a very good answer. I mean, you can obviously use the Cranfield paradigm around the retriever, but there's clearly some sort of query augmentation system that's going on. You know, you definitely, you know, we do it with our RAG systems, but you can see it with all the commercial search engines. Type in a query, it spins up 6 or 7 variants, sends off multiple searches. You know, maybe searches multiple searching systems. And that paper about the distracting effect is definitely very interesting because it really it highlights that you don't just treat this output as if the same way you treat a user looking at it. Yeah, a wider question about sort of what pipelines look like. Yeah, I don't know. It's the honest answer. But it's a good question to ask because you know it is a very different kind of setting.
Thank you, sir. Nice presentation. Sir, if you replace everything by LLMs, then the chances of fake query may be generated. And the relevance statement, maybe I don't think so will provide 100% correctness. And again, how it is the evaluation map score is primarily on the probably English language. How it will behave if we consider the Indian languages, how it will work. Because I don't think so Indian language, these models are quite good efficient as it is English.
Look, I don't personally have any experience in working with Indian languages, so I can't answer that
Any
specific.
kind of logic system. Yes, I'm talking not any English, any kind of logic system.
And I think you asked a very important question. I don't know how effective these things are at dealing with low resource languages. You know, certainly in this query simulation work, so we just had a paper at CIKM where we wrote one of the first papers about query simulation, but we've also recently written a paper saying, yeah, it works, but not as well as we thought. You know, the LLM isn't as, if you ask the LLM to pretend to be 100 different people and to come up with 100 different queries, it does that, but they look different to the queries you would get if you ask 100 people. That's got nothing to do with language. But you know, one should be checking all of these components in many different dimensions. And the coverage that LLMs have of low resource languages, I'm sure is a very important question. And I don't know, yeah, maybe somebody else has some thoughts on that, but I you know, all of what I've done is very much been focused on English, and I've given you a very English-centric kind of bunch of research papers. So I don't know how well this works in those other contexts. I guess the one thing I would say is that given that it does appear to be working quite well, it would certainly be worth exploring the possibility of using them in these in low resource languages. But you probably have to think differently. You're never going to build an LLM in a low resource language. So you're going to have to take an English or a Chinese LLM, and then you're going to have to look at translation or something like that. So you probably need some sort of different approach. Thank you.
Which is more the comment about what is the goal? Basically, the goal is to provide relevant answers to people. So ultimately, they could be people who judge if it is relevant or not. And basically, if people say that it is not relevant, if they are bronze evaluated, probably it is not relevant. But yeah, there is also a problem with the human people. This same answer, which is a real problem. So probably I don't want to keep some kind of relevant information. Where one I don't want to have now. So I think that this document is not really relevant. What do you think about that? What is the trade-off between human feedback on one side, but we are doing that to people on one side, human consider feedback basically. But on another side, there is also this bias about, for example, a real world consequences of some biased answer.
Yeah, I mean, I think the most important thing about using these tools is probably to understand them, and to understand the limits. We were surprised when we wrote this recent paper in CIKM where we discovered that it wasn't as good at simulating people as we thought it was. So I think you know, what I think just having the best understanding you can get out of the LLMs to understand what they're capable of, and also very much understanding what they're not capable of. And then knowing, and with that knowledge, you can hopefully then know when it's time to go to human judgment, actual real use.
Who we test users?
I mean, I'm sure there are examples of time. I mean, you know, Ingo and I will know from doing user studies that, you know, you have to be careful in user studies. You know, if you bring somebody into a lab and sit them down and show them a system, actually users are often quite positive, and they often sort of say, oh, this is a lovely system. Yeah, I'd love to use it, you know, and then in reality they don't. So you know, there are biases in every measurement that you come up.
This was my second question actually, because I have to kind of humans where I have to make quality feedback whether I use it myself. It was really not so easy how my users told you. But
There are some interesting questions though. I think there are ways of asking questions. You know, there was a good story from Google a few years ago that they would ask people. There was something on the slides a while ago. I skipped over it. There's something called your money or your life queries. So Google and Bing paid particular attention to queries to do with money and to do with health, right? Your money or your life. It's a weird phrase, but your money or your life queries is something that they spent. And they actually put a lot of effort into thinking about how to ask those bronze crowdsource workers about, you know, this financial page, would you trust it? And they would say things like, would you spend money on this website? You know, it wasn't sort of like, is this relevant? They when they switched the question to, would you spend money on this website? Would you trust your child's health with this advice? They would literally ask those questions, and they would get better quality answers out of those.
yeah, but example from South Park. I think that there are real examples that when people decided to do something because they were encouraged to do it.
Yeah, no, definitely as well. Yeah, no. I mean, none of these methods are making.
There's one more question there, but how are we doing on time? I just want to check.
Yeah.
Yeah, just one last question maybe. Yeah.
So I was also working on synthetic data on like where LLM is creating information out there. So the main thing what I faced was that like LLM was not able to frame questions just like humans. So I tried all kinds of generation parameters here and there, and also tried RL. Somewhere I'm failing in that. So do you have any suggestions regarding that?
Yeah, I should probably put you in touch with my students, and you could see what she was doing. I mean, we had a paper that got into Big Tier in SIG-IR last year. We actually had a lot of trouble getting it accepted because a lot of people were eventually someone quietly contacted me and said, look, everyone understands what you're doing, but they're really worried that you're just pandering to stereotypes. And so we're you know, that's why this paper is not getting accepted. And so now I personally think it's worth having a go and trying and then understanding whether you're getting stereotypical answers or not. I mean, so we tried to you know, we read some papers, we understood the groups of people that we were wanting to simulate, which was maybe older people or younger people. We read some papers to try to understand how those people were how those people we ran a bunch of tests, but I know that Bhaskar would say, well, but you didn't involve the actual people themselves. You know, so whoever we were getting to do the simulation, we didn't get groups of older people, or groups of younger people, or people from particular minorities. So you know, I can only suggest that one would come up with sort of more thorough testing, maybe more examples that you could use for fine tuning. But yes, I don't have a very good answer for you for that. I'm very comfortable that we did that work because, as I said, current test collections have a very limited demographic that generate those data, and that in itself is a problem. But yeah, no, I don't agree that, yeah, we were also having similar challenges.
Yeah, it's like the main problem was like the structure of framing the question. And somehow the LLMs go and just do some token matching with the context and come up with the question. Even if I try to like tweak with the generation parameters or any kind of fine tuning or something like that. So I was like really struggling a lot like for the last like 3 to 3 months.
I mean, so let's have a chat at lunch because clearly we've written 1 or 2 papers, so maybe if you could take a look at those papers and see what we've been doing. We haven't solved it, but yeah, I share your, we've also been surprised how it wasn't as good as.
Okay, thank you.
And let's thank Professor Sampson. Pleasure to present you with.
Oh.
Okay, we can go downstairs for lunch and maybe gather here at around 2 p.m. For the next session. Thank you.
By the way, your here are yes, not but yeah, sure. Yes, was great. Other than 1.9, but you know, I think right. Exactly, that's what I think. Yeah. The effort that right. Oh, the was actively in the only the derivative that's in the database. I think I don't know. Yeah, not the table are not available. It's not there. Yeah. Yeah. You have
Hello, everyone.
Well,
We're going to start the conference paper track. So we will have 4 papers. And the first presentation will be from Sandeep Purwal, automating exam evaluation using generative AI.
Good afternoon, everyone. I'm Sandeep Sakai, presenting automatic exam evaluation generative AI. We are from Vijay Mumbai. This is the outline for the presentation. So we know that we went to the traditional exam system basically in India where the people don't prepare the exam and those are evaluated by the examiner basically. And this volume is increasing day by day because the number of education institutes has increased. And rapidly our technological advancement has also happened and lots of technologies came into existence. And recently GenAI has came into this, and it has shown its scalability and consistency over the different applications. So what we did, we tried to understand the LLM, but along with the LLM, the LLM also, the small language models also are out there into the research, because before this there was one discussion that what about the regional languages? Because when you have English, it is widely used across the different regions or different or in the complete world. But what about the regional languages in India? We have the for each state we have at least 3 to 4 languages basically. And then can we have a small language model to evaluate them, because we have these schools in the region also. So we tried different languages currently in English with the different models. What we found that whenever the students are answering there, they have the current system which the people have proposed. Those are subjective question answering systems are there where we can directly evaluate them. But it has found that some of the regional languages, some of the domain specific evaluation is become very difficult or challenging to evaluate them. Also, we require the LLM which are existing. They should be fine-tuned or they should adapt to the domain specific information, because we have the standards from first to what is the engineering, medical domain, and etc. So we are evaluated in different zone also, and also the different languages which are considered into the picture. So when we tried the evaluating on a different LLMs and SLMs, we found that the GPT 3.4 architecture has got the better results. We tested on one of the publicly available data set, which is on Colab, and we divided that thing and we answered those questions. This data set consists of 2 human evaluators already given the answers for these questions, and then we evaluated that thing. See, the most important thing when we talked about this comparison, we found that the model selection, not only the model selection, but the answer, the type of question, context, the mindset of the people who are writing is also matter. And we use different levels. The quantization is nothing but to how the model can run faster. We have tested on this thing, and then we have scored the difference. We have recorded the different answers from that. We kept 10% error allowed from the UN level, because Mumbai University has the clear-cut guidelines that the 10% variation in the answer, because normally in the Indian system, there is a answer person change the evaluate the answer books, and there is a moderator after that who moderates them. And the evaluator and the moderator 10% deviation is allowed. If it is more than that, then they say that there is an issue with this paper that need to be re-verified. So there are 2 evaluators, so we consider this 10% variation in the answer given by the system and the answer given by the human evaluators, and then we evaluated that thing by using the LLMs. This is the architecture we have used for this hardware setup. Basically, we use for the testing that. We found that the different LLMs have given the different performance with respect to the both evaluators. We know that a same paper evaluated by 2 people or 2 teachers will have a different answer, different mark basically. They cannot be matched. There is a variation always. We know that because that's a human interpretation. So same thing we have considered when we evaluated the different models for different things. We got the different variation in the answer and the accuracy varies basically. Also, this SLM has a different parameters. So we say that the architecture which has a parameter less than 8 billion, those are covered with SLM, and the more than that will go to the LLM. Then we found that the ChatGPT is working fine. The GPT 3.4 model works fine. To fine tune that thing, its accuracy enhances near about 73%. That is the one of the achievement. Other model, they after doing the fine tuning also did not work. So which means that whatever the existing elements you have used them as it is, they are not going to use the answers properly for the regional languages. Then what we did the carry out this analysis on some of the engineering studies like C pointers or C++, the C books basically, and then we did the topic-wise analysis rather than complete book, but the topic-wise like pointers, sorts, and stuff. And there's a huge variation in the answers, because sometimes we say that some students are good in a particular topic and some topic they are not good. So we can do that kind of analysis. So we try to evaluate the system in that way. So we found that on pointers we got a better answer compared to the other topics. Then we found that the GPT model without fine tuning also giving a better result, but if you fine tune them, you will get a good thing. LLM outperforming SLM because there's a size, the context, the writing style, the mentality of the person also doesn't matter basically when they write the answer. And the model performance doesn't the size. If you have a good large model, it doesn't guarantee you that he will give you a better result. So this is one of the observations which we found. Then what we did, we conducted the models testing on the RAG also, And we found that with RAG we got 78% accuracy, and without RAG we got near about 66%. This we have done on the Maharashtra State Board books, which is on the 6th standard book. That is the State Board book. For the science, we conducted that experiment where the answer and the ground truth is also provided. So we took that 6th standard books and we provided that and we tested that and then we got this result. Also, this now we are using in we are evaluating that in one of the school also. Then second experiment we carried out, live experiment we carried out with the third year BTech students for the software engineering course. And we have given them different questions to them. With them, we asked them to evaluate that thing or write the answers for them. And then there's a human evaluators we kept who will give a score to those answers. And then same thing we carried out with the LLMs. And then we found that with RAG we got 70% accuracy which is matching. And without without RAG is 48%. So that is a significant improvement which we found with the RAG. And this is the live testing we carried out with the last year, third year students for the software engineering course. And this can be extended further. We tried out artificial intelligence also, but we failed over there because the lots of equation and the way of writing is varying. Basically, the artificial intelligence course. So it has been found that the LLM, though they are performing, but some of the SLMs are also giving the good result. So size doesn't matter, but how the model is learning, that context is really matter. The adaptation is really important. The domain adaptation really matters basically. And fine tuning the model really boosts, but ChatGPT or the GPT 3.4 model are almost giving a better result if you don't fine tune that thing. That is the thing. And RAG is providing a substantial improvement in the overall outcome of the result basically. So what we are thinking, we try to work further with the OCR. We tried that thing. We spent near about 8 months on the OCR because whatever evaluation we did, we asked the students to type those answers on computer. Now we are moving with their writing. When we write, sometimes we scratch the thing. We write horizontally, vertically to put a figure or something for the equation. So we are working on that. Almost some of the parts we have covered. So once we capture the OCR, right now 2 months ago the Android Professor Android also invented that for the table also you can extract the data. They have given that API also. So that is also useful. So we are working on that OCR part. So once we do that, we can do the handwriting evaluation. Whatever answer books wrote by the student in the handwriting, we can evaluate that. And so that is one of the upcoming work which we are doing. These are the references. Thank you very much for the listening to the presentation.
Thank you very much. Right on time. So we have some time for a couple of questions. Any questions?
Have you tried instead of fine tuning? So instead of fine tuning, have you tried in-context learning or something like that?
No. But we just instead of fine tuning, we just whatever existing model we create that thing. Then we tested that. But whatever thing
Basically, my question is if you fine tune, you have to do it for different domains.
Yes.
And you want to generalize it for multiple domains. So
Right now, I don't want to generalize because when we talked about the very specific subject wise, because if you go very specific subject wise, it will learn better way and it will answer more better rather than generalizing. That is the thing which you are moving at.
No questions? Thank you. Thanks very much for your presentation. Okay, so the next and second presentation is from Nilanjan Sinhalal on soft prompt improves direct speech, direct search responses.
Thank you. Good afternoon, everyone. I'm Nilanjan, a PhD scholar from IIT Kharagpur, and I'm going to present my work on soft prompt improves direct search responses with my co-authors, Pavitra Mitra and Devashik Ganguly. So,
So this is the presentation overview. Let me start with the introduction. So as you can see right now, if you search Google, so Google doesn't generally change anything in their interface. So this I am feeling icon, I'm feeling lucky icon is still there. There is a button that you will find. So they never change it, even if people don't use it. So they don't change anything if it is extremely necessary. So if you find that if you search something in Google, it will something it will give a generative response first, and then it will give the general list of the rank outputs that we generally get. So this is specifically important because people are now moving from this searching to this generative responses because it will like help you to dig out more information without searching any more further because it will be for you. It will make the things easier. So to do this, the very easy step is the zero-shot LLM-based generation methods, where you just use this query that's provided by the user, pass it to an LLM, give a very simple prompt like answer the following question, you give the question, and you get a generated output. But this is not necessarily a very good output most of the time. So what we usually do is we take this context, the results, such results provided by the research engine, and use it as a context. And maybe we can prompt like use the context to answer particular question that we are giving. So this is the RAG-based method. So in this work, we are trying to focus on the zero-shot method, not on this RAG method for some specific reasons. So what we found is that if you are searching for a particular query, the query can have different variations. It could have some generic variations of the query. There could be some more specific variations of the query. Now, if you give these queries to the large language model, it will generate different kind of output, even if the intent was really very similar. Now, this is more true if you are giving it to a very smaller model. The smaller models are much more affected with a slight change in the prompt. So, is there a way to select some of these prompts, basically questions, in an effective way so that we can directly give it input to the model and get a much better output, much better answer directly? So, this is the question that we're looking at. So, I've given a very simple literature survey. These are the very first papers that have represented that soft prompting is possible. Basically, large language models can generate the prompts by themselves, and it works really well. So recently, there are many works that they're using it for many works. So this is my proposed solution. The solution is that if you are taking a single query and asking the model, instead of that, whether it will be possible to make different variations of this query and ask the model the same question with all these variations. So for that, we are taking 5 variations and we are training a model, GSEG model. That model actually filters out some of these questions if necessary. So there are 2 variations where we are directly taking these 5 variations generated by a large language model, providing it to the large language model for answering. And the second stage where we are using GSEG, which actually reduces some of the questions. Maybe there are 5 questions, it will reduce it to 2 or 3, something like that, and then generate the prompt and then ask the question. So these are the experimental model that we have used. You can see here. So only Llama 3 is the smallest model here. Rest of them are like 20 billion parameters and some unknown model. So these are the dataset that we have used. These are very famous question answering dataset. That's specifically the what it has a question and answers, along with the context that we are not using in this work right now. And CNNGM, which has some news data, which has some paragraphs and some summary information for both. These are the trainings. So these are results where we have taken the different variations. We instructed a particular model to generate, let's say, 1 variant, 2 variant, 3 variant, and 5 variant, something like that. And the query lengths also we have measured. And we have seen that generally for this kind of datasets that we are using for the validation datasets, the Gemini model is a better model. It is a more robust model across these variants. And this is the final result that we see. So overall conclusion on this result is that if you are using this GSEG model, which we have just trained to reduce some of the questions, it actually gives a much more improvement And LLMs with some variants actually give you a better response from the baseline that we have used. So this is the main work. Thank you. And you can have some questions, you can ask.
Brilliant, perfectly on time. We have plenty of time for questions.
Can you go through that pipeline?
Yeah,
right?
sure. Yeah.
Yeah, so there is an instruction and then you try to create variations of that instruction, right?
Yes. So here what is happening is that there are different queries that are being generated. So this instruction will be a little bit misguided, but yeah, we are generating different versions of the query. Probably you are also talking about that when you are not able to do it. But somehow it works for my problem, and I've done different problems with generating questions and it simply works. Maybe it is based on some models, or the type of prompt that you're using could be the reason for that. Yeah.
So is there, so are you also trying to score them or something like that?
Yeah. So
Scoring
them is only for the GSEG model that is fine tuned.
Hmm.
So for the normal model, it will take all the 5 responses and generate a particular prompt from all the 5 responses. If you are including the GSEG, it will just basically rank them in certain orders, and it will reduce some of the questions.
Okay, so in the context of squad, for squad question, you just have the variations of that question itself.
Right.
But in that factor data set, it can be of multi-knob and different types, right?
Right. But we instructed the model to generate a very simple question. So even if it is like paragraph, it will generate a question out of it.
So it's dependent on factor, but also like I think each of those factored answers might have completely different questions which are not even related.
Right. It is possible, but if we are generating questions from a particular topic, let's say a particular document, the possibility is that it will belong to some of the topics. So it is of course very true that a particular document can have thousands of different questions, right? Even a simple question can have different variations. So yeah, that could be possible. Yeah.
Okay, so did you like measure anything on regard?
No, not on this work actually. Yeah.
Okay, thank you.
Any more questions? Thank you. Thank you very much for your presentation. Is Dia Sana online? Can you please confirm if you are presenting your slides online?
Yes. Hi.
Okay, so if you could share your screen.
Hi. Is my screen visible?
Yes, we can. If you could make it a full screen.
Okay.
Yeah, you can start now, and we will have 8 minutes, plus 2 minutes for our Q&A.
Thank you. Good afternoon. I am Dia Shah from TCS Research presenting our paper on Convert, a framework for evaluating confidence and variability in large language models. This work is co-authored with Dr. Manjira Sinha and Dr. Tirthankar Dasgupta. As LLMs are increasingly deployed in high-stake domains such as governance, law, compliance, correctness alone is not sufficient to measure the LLM's performance. Even when answers appear fluent for specifically for small language models or lightweight models, often show inconsistent behavior across repeated or paraphrased queries. This raises a key question, which we are trying to address in this work, that how reliable is LLM beyond surface accuracy? This slide shows a real example of a confidence failure. The model is asked to extract a structured information such as the accused organization, crime, action taken, and investigating agency. When the user expresses doubt and asks the model to regenerate the response, the answers change or include incorrect facts, despite the source text remaining same. This inconsistency signals how low confidence in the model's output. We define confidence as the consistency and reliability of a response across multiple iterations. A confident LLM model should converge toward a stable answer when questioned repeatedly rather than drifting or hallucinating. So there are one more issue in LLM responses. We have observed that we define these phenomena as variability of LLM. Variability issues emerge even more clearly for the paraphrased queries. Here, the same question about a federal judge's mandate is asking using different paraphrases. Although all the responses seem plausible, the answers differ subtly, indicating instability in reasoning. Here, we are also asking the top industries alleged for gender discriminations, and they are giving the LLM in question is giving multiple organizations, and all of them are correct, but it is showing it is differing from the answer. So this is our framework. Convert quantifies the confidence and variability using a graph-based formulation. We construct a query document response graph and compute distances between responses using graph edit distance. This allows us to capture structure and semantic divergence, not just textual differences. To compute variability, we analyze how responses differ across paraphrased queries using query document graph representation. The higher the structural divergence between responses, the higher variability score. This is for computing the confidence. We form a response graph where nodes represent generated answers. We then apply shared nearest neighborhood clustering to identify stable response clusters. A higher confidence score corresponds to strong clustering around a dominant response. We evaluate convert on a custom dataset built from sources like EPA, OSHA, and EEOC. We crawl the news data from January 2018 to January 2023, and the news contains mostly workspace safety, environmental, and employment violation news. We then created a diverse question set, and then randomly selected 50 questions from that set and created expert annotated answers for those 50 questions. To evaluate, we have evaluated mostly the lightweight models, and all the model parameters remain less than 8 billion. We have also, but GPT-4o is not among the list. We are only using it for comparison. So for the evaluation framework, we have used one is for traditional models, that is blue, sacred blue, bar score. These models is they rely on reference answers and focus on the surface similarity, but they fail to capture response stability, confidence, and most importantly, what we are trying to address, that if the response is remaining same when we are generating doubt. But we can see that when uh, we are selecting the response with more response which is coming for the convert framework, like with the most degree center, the response with the most degree centrality, it is giving best answer, and it is giving almost similar to the GPT-4o standard answer. Beyond textual similarity, we are also using the relevance. We are also measuring the relevance, coherent, and entailment, and so as I have said that the traditional methods mostly needed the text, mostly based on the textual similarity, but here we are evaluating these responses also based on the Gaussian maxim, where we are where we are evaluating the generated answer is how much is relevant or coherent. So we can see it from here that the generated answer for the convert framework is pretty good compared to other open source models. Mistral 7 billion is also performing well. So if we rank the models based on the convert framework, here we are given some scores. Con score is basically the confidence score that we have earlier formulated the formula, and for the one drawback we have noticed for the convert framework, that there are multiple correct responses can happen, but proposed framework mostly depend on the one particular response, because like as we are saying, which sectors are accused of gender discrimination, these both of the answers are pretty correct, and in that case that our confidence score is pretty low. So, but both of them are correct. So our main observations are GPT-4o has high paraphrase robustness, but Llama 3.18 billion has high confidence, but variability remains. Llama 2 7 billion is the most sensitive model to the phrasing of questions. And for complex multi-entry questions where like similar instances of a same crime exists in the dataset, the retrieval plays a significant role. And answer with high centrality in the graph may not the answer with high confidence. Like I have said in the example that multiple answers can be correct. In that case, our convert framework does not give a good confidence score. And structured repositories improve the LLM performance. Thank you.
Thank you very much, Leah. We still have our question answers. Any questions from here? No? Okay. Thank you very much, Leah, for your presentation.
Thank you.
So the last one
most position is event syntax, a tool for interpreting event anchored all expressions by Kishan Gurmurthy. Kishan. Hey guys, I'm Ramkesh. I work as a machine learning engineer. So let's get started. These are co-authors, the paper, and motivation and the research gaps, right? In modern financial systems, like they rely heavily on the average event-based like reasoning for tasks such as regulatory compliance, tracking, and event trading or stock market analysis, portfolio management, risk assessment, etc. So often these kind of settings, the data or the expressions, the user expressions are not having explicit dates mentioned within them. So let's have a few examples. So, in the first example, so the stocks rally after the RBI announcement. So here, if the LLM has to answer something like this is a statement over here, if that was a question, and the LLM has to answer that. So understanding the context between like the context behind the after the keywords after the RBI announcement that plays a crucial role. So and the follow-up example, the regulation came into effect after the SEBI notification. So even in this case, like the keywords are SEBI notifications, like it's very important for the system to understand what the SEBI notification means, when the SEBI notification was actually like announced and when this notification came out and what is SEBI and etc. Like all the supporting information has to, the LLM has to understand all the supporting information to answer these kind of questions. So, you know the financial reporting or earnings events, right? So the revenue decline after the Q4 earnings call. So the system has to understand what this Q4 earnings call is and when this Q4 earnings call happened in order to like answer the user questions. So talking about the research gaps right now, so fine-tuning LLMs, like most of the benchmarks or the data sets focus on the explicit timestamps, like Jan 25, like Jan 02, instead of actually being event anchored. So and the relative expressions anchored to document time, so like yesterday or day before yesterday or something like that. So it's actually related to a certain like an event. So and after like so this one over here, like they don't actually capture event anchored like expressions in the real time context. So for example, like after the new tax bill was passed, after the Q1 launch, or after the SEBI notification, or after the RBI announcement, so something like this, something that is actually related to the real world scenario. The result of this is so the models look really great on the benchmark, but if you're actually building an LLM system and that is catering the real-time users, so it's hard to validate how this model will be doing in the real-time scenario, and there are often hallucinations happening. So that is one huge gap that we're going to address. And second one is the modeling gap itself, the knowledge cutoffs. So in India, if you want to build a financial application, like we cannot straight up use ChatGPT or Claude as your model of choice. So there are often regulations by some governing bodies like SEBI, and then you are supposed to use an in-house model and an in-house data set in order to like serve the real-time customers. So these models, like suppose if you're referring to an open source model like Pen or Llama, for instance, like these are having some cutoff dates. So this is one of the things that need to be addressed when you're serving the real-time users. So and all of these event-based are not flexible. We cannot like just straight up like write or like regex battle match and then try to like extract these expressions out there. So all of that works, but it doesn't work for a huge user base. So and the gap three is the system level gap itself. So if you're having a huge model and also a huge data set or a huge rack system, so answering the user query in like fraction of seconds is actually becomes very much challenging. So we often end up having high latency and like we often go and iterate over the irrelevant documents and poor deployment decision. So in order to solve this, we need to always use smaller models, so like the model that is pre-trained or like fine-tuned for financial specific use cases. So what we tend to do, so we use this framework and the dataset called event impacts. It's a single data that is having multi-table like classification and unified framework that extracts and normalizes event-based temporal extractions, like from a statement or from a user query and etc. So this dataset classification. So this just go over the dataset classifications and like in the higher level. So we have broadly like divided the dataset categories into four different categories. Like the one is the standard, the other one is complex, and historic and contextual timeout. Standard one is very straightforward. We can just assume like this is something like the Apple stocks are doing great since yesterday. Since yesterday is very straightforward. We don't need extra complication over that, and that works perfectly. And the complex is kind of tricky. So it's something like referring to an event and how far of like the target is from the event. Like something like Dow Jones is expected to go down by 40% 4 weeks after the next Fed meeting. The 4 weeks after the next Fed meeting is something that the model should be able to understand and then like get more information and supporting information before it actually caters to the user query. And historic is something that has happened in the past and then you're providing the reference to that event. The oil prices after the search of RX Spring Bigot. So after the RX Spring Bigot is something that we need to be able to understand. And the context of the event anchored, like access the granted following the board approval in Q4. So it's something like private data. And like we need to understand the system to be able to understand what this Q4 is and when was this board like actually like approve all these like access and stuff. And in order to normalize the user expressions or like the event-based expressions, we are using the hybrid model approach over here. So just to go over the architecture in the very high level. So we have this query like how was the particular company stock affected after Donald Trump was sworn in. So prior to this like user query, our system needs to be able to like take this query into consideration, be able to identify the keywords behind this event. So here after Donald Trump was sworn in is actually the event-based anchor, and we need to be able to like get the relevant tool and supporting information like for this. So for that reason, we actually do the tool calling, and tool calling here actually extracts the important information needed to like cater this or answer for this user query. And then later we actually generate this particular framework undergoes the response generation. So this response generation is going to be having the user query and supporting information that's required to adequately answer this user query. And in that, one of the keywords or one of the parameters is depending on what the actual date the Donald Trump was actually stored in. So and just to go over the data set, so we have a corpus of 5,052 verified sentences like belonging to the diverse temporal expression categories. And so these are like designed in four semantic labels, as I told you, the standard, the complex, the event historic, and the contextual, the event contextual category. So and in order to like in order to extrapolate this data set into into a bigger data set for fine tuning purposes, we use GPT-4, Claude, for actually like generating different variations of these sentences. So and also this dataset was like annotated by the fintech leads at my company, and like we had 5 innovators in the like intro here. And towards the right end, we can actually see the data point itself from the data set. So we have a column, so we have a section called text, which is an example, and we have an entity section, which this is referring to the start of the character of the event based expression and the end of the character of the event based expression. And we also have the text since the IPO last year and the label as well. So the ultimately aim is to generate this label. So moving on to the framework, the first step inside this framework is to extract the event-based the keywords. So in order to do this, we are actually doing like we are using NER-based models. So ultimately, we're trying to classify. We're just doing it as a classification problem and then extracting the event-based extraction problem. So the Kleiner was achieving the highest accuracy compared to the other models like the DBERTA and the ROBERTA base. And the event load itself, so we have different pipelines designed for each category or each label. So for time standard, like these are very straightforward. We don't want any like further post processing, like increasing the computation and everything. So we just directly go about using the caption library to generate the start range and the end range of the for the particular user query. And for the time complex, we use 1.5 1.5D instruct finding on the cost of data set and to generate the standard like labels. And even historic, so over here, what we're doing is before we pass the query to the 1.5D instruct, we are extracting the information from top 5 web pages. And then lastly, we have the event contextual over here. We are going to the Google Calendar API and also we're doing the semantic search on the private data set that we have. And lastly, because of the architecture, we can see that we are using data for the standard, and for complex, we're directly using the 1.5D instruct. And for historic, we actually have the web-based screening, and lastly, we also have the private database. And the results on the discussion part, so Kleiner was one of the highest, Kleiner was leading highest accuracy compared to other models. And these are the log plots. I'm skipping through them because of the time constraint. And we also have label bias accuracy mentioned, and towards the right we can actually see the I think we can actually see the latency, but over here we cannot because of that the small window is open. So I can actually skim to that. So for standard label, the latency is 30 milliseconds, and for complex it is 120 milliseconds, and for contextual it is 40 milliseconds, and for historic it is 850. So conclusion, we actually introduced one label data set, and also we introduced a framework for capturing the event-based expressions from a user query or from a user statement. It will be used in financial application development. Limitations like difficulty. So right now we have it, the system as having difficulty finding nested or closing events. That's one. And other thing is the linguistic variation. So we only limited to English right now and not in other languages. All right. Thank you, guys.
Thank you very much for your presentation. Do we have any questions?
I have a question with regards to the labels. So in this particular data set, it was with like the Ramadan or other festivals. If it is, let's say, it's with respect to some other country, there will be different festival names. So how do you identify different checkpoints in the label with respect to like festivals or other events?
Festivals and other events, I think these can actually be looked into as historic events because of like the fact that everyone knows about it. So that's the reason like we would like to put that as a historic category.
But if the models themselves don't have any knowledge about
Yeah, no, so we curate the data set and then we like fine tuning the models based on this data set.
all the festivals go.
Yeah.
Any more questions?
So my question is like, why do you think that basic reasoning model won't be able to identify this timestamp? basic reasoning models will be able to identify these timestamps, but whenever we are actually catering for the financial customers, the time is very much important to us. We cannot actually take more than 1 second or like more than, let's say, 10 seconds or 15 seconds to answer these kinds of questions. And also, reasoning models are actually computationally very expensive. So at the end of the day, you are using tools, the reasoning model must be there. That will be selecting the tool based on the ratios. Yeah, that is only like a one-time process. It's over like expanding the data set, you can find it. The inference time latency is actually very small compared to the other reasoning models. Okay, so you are making a dictionary of this information? Yeah. And we also open source the data set and the tool also, and it's GitHub on the base. Guys, we also have some merch if anybody can touch their t-shirts and pants, like hit me out with a question and collect your t-shirts or pants.
Thank you very much for the that's the end of conference track session. So I think I can hand over to Thomas and Courtney for the second part of national.
Okay, now the Hashot presentation. So offline presentation we did before lunch. Right now, all the video presentations are there. So first video presentation will be of Pagi Hassan's. Please play the video.
Mike.
So sorry, videos are not working. Fatih Hassan, are you online? Probably no. Muhammad Rafi, are you online? NLP Fusion, anyone from team NLP Fusion, are you online?
Yes, ma'am.
Can you present your paper?
Yeah, sure.
Share your screen and present the paper if possible. Okay.
Yes.
You can start.
Okay. Is my screen visible?
Yes.
Okay. Thank you. I'm Asha Hegde. I'm here to present a paper entitled Hezok Meme Enhancing Hate Speech Recognition in Bangla, Hindi, Gujarati, and Bodo memes using multimodal multitask transformers. The co-authors of this paper are myself, Asha Hegde, Sharal Koilo, and Amritkala M. Shetty. So, with the rapid growth of social media platforms, memes have emerged as a powerful medium of communication, combining images and text to convey opinions, humor, and social commentary. While memes enhance user engagement, they have also become a vehicle for spreading hate speech and offensive content, often in subtle and implicit forms that are difficult to detect. So the challenge becomes significantly more complex in the case of multilingual and multicultural contexts, such as India, where online content is created in multiple Indic languages and frequently includes code mixing, cultural references, and informal expressions. So the traditional hate speech detection systems, which are largely text-based and focused on English, and fail to capture the nuanced interaction between visual and textual cues in such memes. So, to address this gap, the HESOC meme shared task focuses on multimodal hate speech detection across four Indic languages: Bangla, Hindi, Gujarati, and Bodo. So, highlighting the need for models that can effectively integrate visual semantics with linguistically diverse textual content. So, okay. So, so the task is, as I said, it is a multimodal and multitask learning. Here, as the data sets we have received are both a mixture of image and text, with the modalities, with both the modalities. Uh, uh, so as we can see, there are three different tasks given, like sentiment analysis, sarcasm detection, vulgarity detection, and abuse detection. And here are the examples of the slides. And as I said, the goal of the work is to detect the HESOC meme in the given data set covering four different languages. So here we have used a separate text encoder and image encoders, and we have tried a different set of combination of text encoders and image encoders. For Bangla, we XLM Roberta large and is the text mod encoder we have used, along with the image encoder convex small. And for Hindi Roberta, and for images, we used ResNet 34. And for Gujarati, we have used Gujarati Bird for text encoder and ResNet 18 for image encoding. And for Bodo, we used MBird for text encoding and ResNet 34 for image encoder. So these are the best combination of encoders and decoders what we have used in our proposed approach. So the fusion strategy is what we have proposed here is the late fusion. Multimodal fusion of text and image features was conducted using the late fusion strategy. The text encoder and image encoders output embeddings were first used, and then we have, this a combined encoder is then used for the dedicated classification heads to predict the different tasks. So here is the hyperparameters what we have used to fine tune our transformer model, and here is the result. The performance of the proposed models for different languages. Comparatively, we got good results for all of the languages. So for Bodo, we got we stood first in the shared task, and for Hindi and Gujarati we were second, and for Bangla we secured a fifth place. So here are four references, and to conclude. The multitask learning approach, optimizing for hate speech detection, offensive content classification, and sentiment analysis, improved generalization across various linguistic and cultural contexts. The proposed model secured optimal results, optimal F1 scores for all of the four languages with a good ranking. And these results highlight the framework's ability to address the complexities of multimodal hate speech detection in low resource Indic languages. Here are few references. Thank you.
Thank you, Asna ma'am, for your presentation. So from audience, you can ask any question. Anyone want to ask a question? Okay. So thank you, Asna.
Thank you.
Next, one from Golden Ratio team. Anyone wants to present online? Okay. This presentation will be Hassan's presentation.
I would like to present our work like bridging modalities for hate speech detection. And so, as you know, this hate speech detection in meme is when it's as a text and image is bit difficult due to the nature. For example, sometimes the text is implicit, and also sometimes this image is very different compared to what is like text is saying. So together it's become like might be hateful. So this is a bit challenging to like detection. And for this competition, we have used only official released dataset by the HACCP 2025, and that cover like Bangla, Bodo, Gujarati, and Hindi, and which has like 5 part of classification. And there was training, total data was 5,000, and test data was like 3,000. And we have like used this 9:1 ratio for train and validation. And for we explored like three different approaches, like prompt-based inference, and then cross modality, also text modality pipeline, and finally we did ensemble the result. And to get this additional information, what the organizer has provided, for example, this OCR, we did get additional information from the LLM, like the image description and the translation of the OCR to get more information. And for LLM, we tried this both zero shot and few shot. And our result was like we came top in 3 tasks, and second position in the Bodo task, and our combined ensemble models actually perform better. And in conclusion, actually, our multimodal fusion significantly improved. Also, this prompt-based LLM encoder model also help, and also our this more description of the image and translation of the text also quite helpful. And finally, the ensemble was the like given as the best result.
Okay, thank you, Qadi Hassan. He is not online probably, so we can't take any questions. And next will be first team, and this team is from the Pakistan.
Greetings. My name is Ahmed, and this presentation is about the participation of FAST University in HAZOC 2025 in hate speech detection in Hindi memes. These are going to be the contents of our presentation. Firstly, we had 7 authors, and as discussed earlier, the affiliation was with FAST University, Karachi campus, Pakistan. If we discuss the dataset description, so the dataset was provided by HAZOC 2025 team, and it contained both Hindi and English languages. The total training samples were 1,133 and the test samples were 767. The subtasks in which the dataset was divided were sentiment, sarcasm, vulgarity, and abuse detection. The challenges that we faced were code mixing, implicit and visual offensive, and obviously the noisy OCR. If we discuss our methodology, which we applied onto this dataset, first of all, we applied lightweight multimodal framework. Then we had some ensemble techniques, which we used in vulgarity. And then we had combination of classical machine learning and deep learning models. Thirdly, and lastly, we had to design some, we had to choose some models for which would have used low resources and produced better results. For the pre-processing part, we removed the URLs, emails, the noisy symbols in the OCR text, and there was a mixture of Hindi and English words, so we converted all of that into English. Then we had to normalize the offensive words because there were variations of those offensive words, so we had to normalize them. Then lastly, we had to produce language-aware tokenization of the OCR text. If we talk about the models that we used in all these categories and all these features. So for sentiment, we had an ensemble approach of TF, IDF, and random forest. Then for sarcasm, we did use CNN model. For vulgarity, we divided it into 2 parts. Firstly, it was based on vulgarity that was displayed in text. Secondly, it was in the image. So for the image part, we used ResNet 50, and for the text part, we used again TF, IDF, and random forest. And for detecting abuse, we used BiLSTM with Hindi fast text embeddings and lexicon features. We did not use transformers because in small dataset, transformers produce a risk of overfitting, and The lightweight models are faster on small dataset. Also, the OCR noise and code mixing, it reduces transformers effectiveness. As we discussed the results, these were the results, these were the FN scores of different features like sentiment, sarcasm, vulgarity, and abuse. The overall score as an average was 0.53 approximately, and the rank we achieved in this contest was 13. As conclusion, the lightweight models did perform well with obviously low resource settings, and the multi-model fusion was really critical for vulgarity detection. Similarly, effective multi-model system for Hindi meme analysis was put to work, and it did produce better results. Then pre-processing significantly improved robustness. Thank you. This was our presentation.
Thank you, Team Fast, for your video presentation. Next presentation will be of golden ratio.
Hello everyone, I am Tanmay Pal and I am presenting my work titled Hate Speech and Offensive Content Identification in Meme in Bangla, Hindi and Bodo, which is co-authored by Anupam Jamatia. Here's the contents. Let's begin with the dataset. Yes. Here we use HASOC's multilingual meme dataset in Bangla, Hindi and Bodo. Each contains image and OCR, where each dataset is annotated for sentiment, sarcasm, vulgarity, and the abuse. So here is the dataset statistics, and here's the example. Let's begin the methodology part. So we proposed a multi-modal, multitask framework using language-specific transformers for text and clip for vision. After that, we use cross-attention for the fusion, then classification layer to classify. Here is the proposed architecture. So we take OCR and in the image of the meme for as the input. Then we use encoders. We use language-specific transformer models for the text and clip for the image. Then we fuse those using cross-attention model. Then we use classification layer to classify. So for the loss function, we use weighted cross and true loss for sentiment, and for other classes we use weighted binary cross and true loss. So the result, our model yield 0.615 F1 score in Bangla, which ranked 3rd, and 0.590 F1 score in Hindi, which ranked 4th, and 0.562 F1 score in Bodo, which ranked 10th in the shared task. In conclusion, we proposed a multi-model, multi-task framework which demonstrate the effectiveness of language-specific text encoder combining with clip, and we achieved a competitive performance in HASOC 2025 shared task. And this is my presentation. Thank you all for listening.
Thank you, Team Golden Ratio. The last presentation is on behalf of Kriti Kumari.
Greetings everyone, my name is Sharad Prakash and I'll be presenting our approach to the HASOC Challenge 2025 on behalf of the NLP team from IIIT Ranchi. A bit of background regarding the task itself. The challenge tasked us with creating deep learning models for classification of hateful memes in 4 different languages: Hindi, Gujarati, Bangla and Bodo. The dataset was provided by the organizers, and the Bangla language had the highest amount of data with over 2600 different memes in the training set. In comparison, the Bodo language had very less data with about 378 images, and this did result in different approaches which we took for the processing of individual languages. Since no validation data was provided, we decided to split the training dataset into 90:10 ratio to get the validation dataset. Our entire methodology was divided into 2 sections. Phase 1 included usage of text-only models, and even in that we divided the usage of backbones into 2 sets. The first was to use multilingual backbone like the IndicBird model hosted by AI for Bharat on Hugging Face. Usage of IndicBird gave us a macro F1 scores greater than 0.55 for Hindi, Gujarati and Bodo. However, it did not result in significant results with the Bangla language. Next, we decided to use monolingual models fine-tuned on specific languages and used Hindi BERT, Telugu BERT, and Bangla BERT, which are provided by L3Cube Pune. However, they also did not result in significant improvement, and for Bodo, it even worse the results. In the next phase, we decided to use the images that had been provided for feature extraction. And for this, our decision was to use the clip-based encoder. And for textual feature extraction, we again decided to use IndicBERT or the language-specific fine-tuned models that were available. For the fusion strategy of the image features and the text features, we initially tried to use cross-attention. However, since clip is trained explicitly on English text and image pairs, the model was not able to capture the meaning properly, and in the end we decided to go ahead with simple feature concatenation. With the multilingual text backbone, IndicBERT in this case, we were able to increase the F1 score of Bangla from 0.45 with the text only model to 0.58 here in the multimodal model, and for Gujarati it went from 0.56 to 0.59. Now, the monolingual models, that would be the language BERT here in this case, Hindi BERT, Gujarati, and Bangla. These models helped us to surpass the F1 score, the threshold of 0.6 for both Bangla and Gujarati, and also for Hindi. This gave us our maximum score of 0.59597. Bodo language was not able to benefit from this multimodal architecture, and in the end we found that including the images only worsened our results. So for the final output, we decided to use the text only model for Bodo. This is our proposed architecture for the multimodal clip and text only model. This has 4 separate classifying heads for each of the tasks: sentiment, sarcasm, vulgar, and abusive. For the training methodology, we decided to use Kaggle for our training platform. The optimization was done using AdamW with warm-up and learning rate scheduling. For training strategies, 2 different training strategies were experimented with. First was cumulative training. Cumulative training was done so that this layer just before the classifying heads, which is shared across all the 4 heads, would be able to learn some shared logic from all of those heads and maybe help the heads to learn from each other. However, this was only beneficial for Bodo and was not useful for the other languages. The sequential training was done such that each of those classification heads was trained separately, and the remaining heads were frozen. This training strategy was used for Hindi, Gujarati, and Bangla, and the cumulative training strategy was used for Bodo only. These are the final results that we achieved with our models. Hindi getting the 3rd rank, Gujarati and Bangla getting the 5th and 6th ranks respectively, and Bodo getting the 9th rank. Bodo gave us a bit of challenge here working with the DL models, because the language itself was a bit of low resource and we were not able to find enough pre-trained models for feature extraction. The multimodal models, which use the clip-based image feature extraction, was able to increase our F1 scores much more compared to the text-only models, and this did help us with Hindi, Gujarati, and Bangla. The vulgar and the abusive classification heads were the ones that generally converged the fastest and also achieved the highest validation F1 scores, generally greater than 0.7 across all of those languages. The Bodo language, however, was a bit tricky here, and the text model in case of Bodo remained superior to the multimodal model for Bodo. However, we also saw significant overfitting across all of those languages, and the training for Bodo model was actually quite unstable. Thank you.
Thank you, Team Kriti Kumari. All the 30 presentations are done online, offline, and the video presentations. And thank you, the HashOp participants. And I am giving the mic to Sir if you want to conclude.
I think thanks Koya again for everything. Thanks also because of so many talks that you talked in the 17th, that's quite nice. Also, thanks for your efforts, I guess, in pushing it. So let's move on to the next session, which is Libre.
Can you please share your screen? Hi, Praveen. Am I audible? Next week. Are you audible, Praveen?
Hello?
Hi, can you hear us?
Yeah, I can hear you now.
Yeah, can you please share your screen?
Yeah, sure.
So you will have 40 minutes for the
Am I audible?
Yes.
Okay. So can I start now?
Yes. Yes, sir. So maybe let's start with a brief introduction about you. Mr. Praveen Kumar Pal is a distinguished industry expert and Nokia of America Corporation with over 20 plus years of experience in optical communications and AI-based network optimization and embedded systems. His expertise spans DWDM systems, transformers, Raman and EDFA amplifiers and advanced overhead level up to 1600 GB per wavelength. He has contributed extensively to next generation optical technologies and the integration of machine learning for intelligent network automation and traffic prediction. Mr. Pal's research covers AIML, generative AI network protocols, GMPLS, BGP, OSPF, and high-speed optical standards, including IEEE 802.3, 400 GB/800 GB, and ZR/ZR Plus ITU-T. His interests also extend to wireless systems, IoT, and embedded real-time applications. He is keen on exploring and supporting high-quality research that advances optical, wireless, and AI-driven networking innovations for the next decade of intelligent communications. Welcome, Praveen. Please start with your talk. Thank you.
Thank you. So good afternoon, everyone. I am Praveen Kumar Pal, working as principal software engineer in Nokia USA. So today I'm excited to discuss how artificial intelligence is transforming the landscape of optical network and maintenance. So specifically, we'll explore how predictive fault detection and predictive upgrades are dynamically improving efficiency, reducing downtime, and cutting operational cost. So before we dive deeper, so let me ask you a question that have we ever thought that how important is the optical networking in our life? So let's park this question in our mind. So I will cover in subsequent slides. So okay, here is my agenda. So I will cover optical network overview, complexities in optical network, customer SLAs, machine learning and traffic alert system monitoring for millions of devices. Then I will provide some case studies. So, So in the optical world, so we lead the world in the next generation optical networking, driving the future of high-speed connectivity with unmatched innovation and reliability. Over the past decade, we have transformed optical technology from 10G to 1.2 terabit per second per wavelength. So when I talk about like last decade means I would just name like 2008 time frame. That time we were used to work 10G per wave per second. That was our capacity. And now in 2025 we have 1.2 terabit per wavelength. That's our capacity that we have increased. So it's a huge jump in the bandwidth per wavelength of the optical traffic. So with this, we carry up to 100 terabits of throughput per fiber. So with all this combined together per fiber, we carry up to 100 terabits. So we are redefining the capacity frontier and enabling the network that power tomorrow's digital world. Okay. So this diagram illustrates how our optical ecosystem spans across axes. This is the layer, and we have metro and core layers. And these are seamlessly interconnecting data centers, enterprises, and service networks. So each layer is built on adaptive optical links that scale dynamically with traffic demand. So at the heart of this architecture lies our 800G technology, delivering massive throughput and spectral efficiency across multiple domains. So it's not just about speed, it's about intelligence embedded in every wavelength. So we cater end-to-end systems from edge to long haul. That's the brief overview here. Okay, so we used to say that we are connecting people across cities, across continents, and then someday, one day, someone says that Nokia that okay, why stop there? So yes, we are literally connected the moon. So with 4G LTE technology, we have gone where no telecom engineer has gone before, enabling connectivity for astronauts. Because when we say global connectivity, then we mean globally, and we go even a little bit beyond. So let's see growing demand of bandwidth. So first is 5G to 6G migration. So as networks evolve from 5G to 6G, there will be an increase in demand for higher bandwidth to support faster speeds and greater connectivity. Next is growing data centers. The rapid expansion of data centers, which store and process large amounts of data, is driving the need for more bandwidth. And next is growing applications of AI, ML, robotics, and autonomous cars. So the rise of technologies like AI, machine learning, robotics, and autonomous vehicles demands vast amounts of data transfer, significantly increasing bandwidth uses. So last one is social media and bandwidth-rich content. So the growing consumption of social media platforms and rich content such as high-definition videos, virtual reality, and gaming will lead to greater need for bandwidth. These factors together highlight the future surge in data consumption and the need for more robust, scalable bandwidth solutions will be needed. Okay, so let's go through overview of next generation technology that we offer. So these are our flagship solutions delivering long-haul connectivity and enabling up to 100 terabits per second on a single optical fiber. So you see here, so this diagram illustrates how we deliver universal Ethernet and wavelength services across our optical transport network, connecting clients seamlessly at any scale. So this provides end-to-end connectivity from our home to subseas or continental links and and up to the mobile connection or laptop connection. So there's the end-to-end connectivity. Okay, so what we're looking at here is a major leap in optical innovation. The ICE-X 800G ZR technology, the industry's first multi-hall pluggable intelligent coherent transceiver. This is built on 3 nanometer CMOS technology. So let's wait a minute here. So what's the big deal here, right? So if you see, these are the pluggables, which looks very tiny. It's like a pen drive size that we used to see, right? So this pen drive size and they are very powerful. So a comparison I would say, like if someone say, okay, let's park a aeroplane in a 2-car garage. So it's like impossible thing, right? So yes, but that's what we have done here. So we packed a giant elephant in a carry bag, and that's the optical transformation that we have did with this GR technology. So it delivers exceptional performance while drastically lowering power consumption for data center interconnection. So this is very powerful and useful for the data centers because it uses very less power. Okay, let's explore the challenges in optical networking. So when we talk about global connectivity, especially across terrestrial and subsea optical links, 3 major challenges constantly define our engineering and operational effort. The first challenge is signal impairment and quality degradation. So over long distances, optical signals are affected by various physical limitations such as dispersion, nonlinear effects, and amplified noise, all of which distort and weaken the transmitted data. In subsea environments, these impairments are magnified due to extreme distances and limited opportunity for amplification or regeneration. Maintaining a high-quality signal across thousands of kilometers of fiber requires advanced DSP algorithms, adaptive equalization, and real-time monitoring powered by AI. So the second challenge lies in the complexity of network control and management. Modern optical networks consist of multi-vendor, multi-domain systems, including terrestrial, metro, and undersea segments. So all these needing seamless orchestration. And third is hardware failures. So managing this manually is no longer feasible. It demands intelligent automation, open APIs, and AI-driven control planes that can dynamically route traffic, predict failures, and optimize performance across diverse topologies. So let's talk about traffic outages and its impact in the real life. So when we talk about optical network reliability, it's not just about bits and bandwidth. It's about real lives and real experiences. So, and here every traffic outage, even for a few seconds, ripples through daily life in ways we often overlook. So let's imagine we are waiting at the airport and flight system lose connectivity. So it will cause check-ins, boardings, and upgrades. Those will halt instantly. Or even worse, during an emergency, and we are not able to dial the emergency number. So that could mean a difference between life and death. So our cities today depend on the networks systems. Traffic signals communicate continuously with central servers for coordination and safety. When these links go down, it does not just cause inconvenience, it can cause grid locks, delays, and even accidents. So even at home, connectivity powers banking transactions, live streaming, and video calls with our loved ones. So whether you are watching the Cricket World Cup, transferring funds, or connecting across continents, in short, the digital world collapses without a reliable network. So here I will cover the penalties and SLAs. So in our industry, maintaining uninterrupted service is not just a goal, it's a contractual obligation. So we operate under strict service level agreements called SLAs, which define the performance, reliability, and uptime our customers expect So any disruption, no matter how small, triggers miserable impact. According to these SLAs, penalties are directly proportional to both the duration of outage and the amount of bandwidth affected. So this means even a 5-minute disruption on high capacity link can translate into substantial financial penalties. Also, it spoils customer trust and brand reputation. So in essence, our commitment to reliability is not just technical, it's contextual, operational, and ethical. So every second of uptime matters because behind every connection, there's customer counting on us. Okay, so let's jump to our AI solution. So as we have seen that optical networks are crucial backbones for global communication, supporting everything from streaming video to mission-critical enterprise operations. However, traditional reactive approaches often lead to service disruptions. So AI introduces predictive solutions, enabling significant improvements in reliability and operational efficiency. So AI-powered algorithms analyze historical and real-time data to detect anomalies before they escalate into major faults. By continuously monitoring network parameters, AI models can identify patterns and anomalies early. So as per our case history data on early fault detection using AI, there is 60 to 70% reduction in fault response time. So here we can see a range of LLM models we have analyzed and integrated, spanning across major ecosystems like OpenAI, Google, Leta, and Meta. Models such as GPT-4.0 and GPT-5 from OpenAI deliver exceptional reasoning and multimodal capabilities, while Gemini 2.5 Flash from Google and Llama 4 Scott from Meta provide open, scalable alternatives suitable for distributed or immediate environments. Each model brings its own strength, from lightweight inference for real-time observability to high-capacity contextual reasoning for predictive maintenance analytics. Our work combines these capabilities to enhance network insight, fault prediction, and autonomous automation in optical systems. So in short, the convergence of these LLM technologies enables a new paradigm where AI does not just process data, it understands the network and predicts its behavior and helps us build systems that truly think ahead. So as we can see here, the use of AI network uptime is increased from 75% to 95%. So this case study highlights how AI-driven predictive analytics is transforming the way we plan and execute network upgrades. Traditionally, network maintenance and capacity upgrades followed fixed reactive schedules, often triggered after performance degradation or customer impact. So using machine learning models, those are trained on years of telemetry data, including traffic growth, optical signal matrices, and fault logs. We built an AI engine that predicts optimal upgrade windows before network failure occurs. So the graph on this side shows the predictive versus actual upgrade schedules. So here, vertical axis indicates the cumulative number of upgrades, essentially how many network elements or nodes were upgraded each point in time. And the horizontal axis shows the timeline in months. So this blue line presents the upgrades that AI model predicted should occur based on the historical trends or optimization algorithms. This orange line shows the real world implementation. So this is often slightly lagging behind the AI prediction due to operational or logistical constraints. So the gap between the two lines visually reflects schedule variance. So we can see how closely real upgrades followed the AI's predicted plan. Okay, so let's go through the challenges. So while AI integration brings incredible promise, it's not without challenges, especially when applied to critical infrastructure like optical networks. Let's look at a few key considerations. Data quality and availability. So AI is only as good as the data it learns from. In optical networks, telemetry and performance data can be incomplete, noisy, or inconsistent across vendors. Ensuring clean, high quality, and continuous data stream is one of the biggest challenges to achieve accurate and trustworthy AI predictions. Next is integration complexities. So integrating AI into existing network management system is not a plug and play process. We have to deal with legacy infrastructure, proprietary interfaces, and multi-vendor ecosystems, all of which increase complexity. It's not just about deploying a model, it's about making AI a seamless part of operational workflow. The last is the cost of training and managing AI models. Finally, the economics of AI matters. Training, tuning, and maintaining models require significant computational resource and domain expertise. The real challenge is balancing innovation with operational efficiency, ensuring that cost of adoption translates into measurable business value. So while AI continues to revolutionize network performance, reliability, and automation, we must approach it with strategic awareness. Addressing these challenges head on to unlock its full potential safely and sustainably. So we have just seen the key challenges with AI integration, from data quality to system complexity and training cost. But let's look at how we are actively solving each of these challenges in real-world deployment. So for the first two challenges, data quality and integration complexity, we have developed a patented solution that revolutionizes network observability. It's a device-agnostic framework that provides a unified data format across a wide range of network devices, enabling consistent telemetry collection without altering the existing infrastructure. So this innovation has been formally recognized with a US patent. The title is Observability Without Changing the Target. So this patent was completely invented and implemented by me. So this approach eliminates the data inconsistency problem and allows AI system to seamlessly integrate, analyze, and act upon real-time network data. Now, addressing the third challenge, the AI training cost. So we are already exploring the potential of quantum computing. Quantum-based acceleration will drastically reduce model training times and computational expenses, paving the way for large-scale sustainable AI deployment in optical networks. And we would like to thanks to Nokia because they are investing $1 billion in Nokia quantum computing program. So in short, we are not just identifying challenges, we are solving them through innovation, standardization, and forward-thinking technology that makes AI practical, efficient, and universally deployable across optical systems. Thank you. Thanks to organizing committee for providing such a wonderful platform to share and discuss innovations and advancements in technology. Thank you. Yeah, any questions?
Yeah. Thank you, Pranav, for giving an insight into the application of AI in the field of networking. Could you please elaborate on how do you actually use AI in your field? I mean, what kind of data you actually use where AI is used?
Yeah, so that's a very nice question. So yeah, so regarding the data, right? So there are basically two kind of data we use. So first is like platform data that our devices produce. So platform means like so first thing like computer, right? Like so computer has to be in a good state. So let's say my laptop, right? That I'm talking with, right? So first of all, it's a CPU and its memory has to be in good state, right? So first thing I have to monitor from my optical devices is that monitor the CPU, its memory, its disk uses, and how the processes are behaving. Each process, is there any memory leak or any process taking up a lot of CPU? So those kind of monitoring we do, that's called platform monitoring. So that's the data we monitor and collect uniformly. So we have like just I shown like the pattern that we have used. So with that, we uniformly stream the data from the devices. So it's unified data across all the devices. So it's very easy to integrate to our learning model. So all goes through telemetry to one of our central database, and so it's basically we use Prometheus for streaming all the data and storing there. And from there we have the machine learning models which pulls the data whatever we stream to the Prometheus, and that's where all the machine learning models runs there. And there are multiple machine learning models. Basically, it's not only one. Basically, few are like look at the logs, few looks at the telemetry parameters. Okay, and yeah, another data set is like so first one I told is a platform data, and second one is like optical data set, which is like OSNR, like what is the noise in the data, what is the quality of the signal, right? And what is the bit error? So all those data is very specific to the optical systems. Those we also stream the same way as we stream the platform data, and those also get stored in the Prometheus, and that's where we run all the machine learning algorithms, and it predicts that if there is any anomalies or if so we also provided some solutions to our customers like EDFA failures. So because in the field EDFA can fail, and if it fails then it's a struck roll to the system, right? Like their traffic will go down, and it may take maybe few hours to restore. Maybe it may take up to 24 hours if they do not have the right spares to change it. So it's very important to predict the EDFA failures. So for that also we have provided some machine learning techniques that we can predict the EDFA failures 2 or 3 days before they actually die. So that also helps us to predict to maintenance that system can be running into the up state, and customers can avoid the traffic impact productively. So these are the kind of system that we deploy.
Questions? Any other questions? Yeah, and then, so this is for my understanding. I mean, so how 6G is different from 5G? Okay, is 6G already deployed trial basis somewhere?
Yeah, actually, we work on the optical side. So 5G, 6G is another business unit that works on, right? So I can answer all the opti related questions. Yeah.
Yeah.
I actually have a question. So when you mentioned that you use Prometheus for maintaining logs, system logs, I mean, Grafana and Prometheus are used for basically system maintenance logs and all of those things. So primarily, when you say you use AI models to predict failures and all of those things, there could be a probability where they hallucinate or maybe suggest that a system might fail, but even though it wouldn't. So probably do you use some manual intervention as well, or is it totally automized? How do you handle those things?
Yeah, so what we do actually, it happens, that's right. But we have put the guardrails so that they do not go beyond the whatever we have trained, right? So we always provide the thresholds, that these are your thresholds and don't go beyond that. So that's how we control the AI hallucination. Yeah, so and we also provide the few documentation, right? So we have all these things in place, but yeah, there are chances that maybe 5 to 10% time it may predict wrong things, and then we have to feedback the data that this is your limits. So we retune the thresholds basically, and when we detect it's a false positive if it is producing.
Okay, so mostly when you have your AI models, it's mostly for your developers or like the people working at your company instead of your clients, if I'm getting that right.
Sorry, your voice is not clear. Say again, sorry.
I'll repeat it. So when you have your AI models where you predict your failures and all of those things, it's mostly for your developers instead. You don't share that information with your clients, if I may. Because
To
if
the
you are
yeah, client, we only give the solutions. We do not share the solutions. Means we do not tell what technology we are using, but we provide the solutions as well. Yeah. So it's an early model. Basically, we do not give the solutions to every customer. It's case by case basis.
Okay, thank you.
Yeah.
Any other questions? Thank you.
Sorry, voice is breaking. I couldn't hear.
Thank you. The wonderful.
Okay, no more questions? Yeah. Okay, thank you. Yeah.
Thank you.
Thank you.
Welcome to the panel discussion industry track. So I am Saptarshi. I am currently working as the head of AI and data science at IC Networks, a renewable company. With me, I have Neil, associate in cybersecurity advisory at Grant Thornton Advisors LLC. We also have Ishan Gurumurthy, who is an ML engineer from KIPL. And on call, we have Sudeshna Saha. She is with PCS Research. So I will I have not fixed any specific topic because we have a variety of audience people in the panel. So I have I just recently joined this company. Before this, I was with Walmart, and my background is in retail. One of us, PM, is working in the cybersecurity domain. Other person is from for developing ML libraries, and Sudeshna is with Physics Research, so she's working on a wide variety of problems involving NLP IR. So we'll keep it very wide open, sharing, everyone will share their experiences on what they're working, what are the challenges they face and how they resolve it, and what are the opportunities and way ahead for this. So Sudeshna, I hope you are able to hear us. Hello.
Yes, yes. Hi. Yes, I can hear you. Hello, can you hear me?
Yeah, you can hear. So, maybe maybe I will start with my introduction, what I am working on and have worked on. Currently I'm working in this company where what they are doing is they're working in the radiology space. So basically, there is a dearth of radiologists in India. So compared to the patient load we have, which is enormous, we have only 10 to 15K radiologists across India. And just imagine on a highway, if there is an accident which happens, which is very common. There will be drunk driving, multiple cases happening across the highways, where like even hospitals are far off, and then even when you take to the hospital, there will be no radiologists at that point of time. So people have to wait till odd hours, and they have to wait till multiple hours to get that scanned and get any further treatment. So, and even the load is so high that there is a lot of wait times. And even for complicated scans like MRIs or nuclear medicine, it's even more challenging. So, what they are doing is basically using AI to accelerate this process while having some form of validation using human in the loop and radiologists, but using AI to accelerate this process. So I'm working on that basically to build systems, foundational systems to improve this speed of operations using AI. So what they have understood and what my understanding is, AI, if somebody thinks that AI can be a replacement for a radiologist, that is not going to happen. AI can only be an enabler and help to scale. And the problem which I mentioned that at night time or odd hours or when there is no radiologist, so then like at least we get 70-80% accuracy, it's better than having nothing. So that's the benefit. So maybe I will request others to talk about their experiences. Maybe Sudeshna, you can start what you are working on and all, and then go ahead on the table. Sudeshna?
Yes, yes. Just a minute.
You can talk about your experience, what you are working on, what are the challenges, what are the things you are facing.
Yes, yes, sir. Hi, I am Sudeshna. I am working in TCS Research. And I'm basically working in the domain of biomedical texts, where I just used some like patients' clinical narratives, like radiology reports, ECG, nursing progress notes, discharge summaries, and also some structured data and build some predictive models. Different types of predictive models like length of stay prediction or discharge prediction like this. So and we are not just support for patients, we are basically working like it's help for the hospital administrators or for planning, like if I predict early predict whether the patient how many days the patient will stay in the hospital or something like this, then the administrator or hospital planner can plan the ICU beds or some wards, etc. So for this, what I feels that for some simple problems like entity extraction, clinical entity extraction, etc., AI like LLM can do like very like they extract entities very good. But when I whether if I give a this is a summary and want to predict the whether the patient will whether the patient will readmitted within 30 days or not. That time the LLM models give biases. Like most of the time, they predict that yes, the patient will readmitted, but the thing is different. And also, we feel the same for some other problems like length of stay or some disease progression time, like disease progression path. If I want to predict whether the patient will recover in how many days or etc. That time also LLM uh, mm, uh, give some biases or some hallucinations like this. And that the thing also occurs with the bio LLM also. There are different biomedical LLM available, so they are also facing the same problems. So that's what I feel in my work.
Thanks. So, I'm currently working as an associate in cybersecurity and thought. So, my role is penetration tester. So, work on penetration test engagements, internal, external, web testing, parts of compliance. Most of them are serving financial services industries or banks. So, they guys provide us with lots of most of their IP addresses and networks. We try to exploit, like we try to break to our records, support stuff like that on the IPs, and we try to find out that actually having any confidential data exposed on their IPs, which should not access it. So recently, like a sharing trend is that we are trying to leverage a lot of AI-based startups. I can give you some examples. We are recently so let's a software that uses elements to conduct all these scriptons and everything is required to make do these penetration testings on automated way. Some other initiatives that we are trying to expand our services in like AI safety benchmarking, AI so we are trying to benchmark some of the AI systems that are using to test for whether the systems are showing any bias in absolute content, because this is not just for customer satisfaction, like customers can get really happy if they are facing bias outputs. You can happy like activating a particular company, but it's also in terms of compliance with regulations, like how the AI app already in draft stage, like it is probably will be in action in 1 or 2 years, and soon like we have to be having all our enterprises, corporates, should be having like their AI systems complying with these regulations. So this is from a regulatory standpoint as well. This is something that many of our clients are working towards in the interest that they can talk about like our roadblocks that they're facing. What is that? Most of my clients are sometimes a little cautious when they are having this idea that their confidential data is going to go into some LLM, into that, into the training process and all. Because like most of our clients, I mean, what they think about AI is that AI and privacy are like completely different entities, like completely different poles. So you probably cannot build an AI infrastructure by protecting privacy. I mean, definitely, like, doing innovations, these are possible solutions, but I mean, there's no that, like,
there's this trust perspective as well. So most of the companies, they actually want third-party AI service providers to be compliant with NIST, ISO, and different certifying bodies before they can send their confidential data to these AI third-party providers. So these are some of the challenges that we are facing in trying to convince our clients to keep using AI services. Yeah, with this, I would hand over to my colleague.
Hey guys, I'm Kishore Gurmurthy. I work as a machine learning engineer. So day-to-day work, I focus on building data sets and for client-specific use cases and fine-tuning the models, like selecting the models from benchmarks and all these things. Apart from that, we also like extensively put our efforts in validating the models that they're using on for serving clients. Right? So that's done, and so even though it is a building part, like we should put a lot of effort, feel like we're actually putting a lot of efforts trying to validate the data that we are using for fine-tuning the models, and then and all these things. So I work on like building the data set and fine-tuning the models, and also like validating them and taking them to production along with GPU optimizations, hosting them, and taking care of the bugs and in the production and all these things. So yeah, that's pretty much it. Do you have some questions? Hand over.
So, next maybe we can talk about like what is the AI? AI models may go great, but when it comes to implementing them in a particular domain, be it a medical domain, be it cybersecurity or any other product. So when you go to the customer, so there is always a lack of trust. So you use AI, but there is no 100% like accurate solution with any AI model. So how do you build that trust in the system that whatever AI is generating has a factor of trust associated with it, which people can connect to? So what is the way? Like there are different ways which different people take different companies here. So like for example, in my current company, they are having human in the loop, they are having QC, quality control systems. So there may be different other ways. Like you create a whole pipeline where you have domain experts or those who understand the domain who validate the things at certain level. But then what is the way it's done in your organizations?
Yes. So if I talk about clients, like complete trust works in consulting is third-party intelligence and third-party risk assessments. So in most of the cases, like people who are setting out information security positions, they're not into quality assessments and all those groundwork that's done in order to guarantee that the data quality or the AI system is safe and sound. They're not just with those certifications which ISOs, like NIST, and then different regulatory bodies are providing. So the main thing that most of our clients say, whether it be like financial services companies or banks, or maybe e-commerce platforms, they are doing is going for a straightforward third-party intelligence assessment, third-party risk assessment. But some consulting bodies, I mean, Big Four are pretty much into PRM and third-party risk assessments. So this is what maximum of our clients for rather than taking risk with the quality assessments. Checking quality and quality, everything.
So Desha, what's your experience like when you if I understand it's like you were doing research, but maybe you were also working with clients or whoever is taking the end product. Like how are you building trust in your system on the quality of AI model or the data which you are generating? Sudeshna?
Yes. So, in clinical domain, that transparency is very important. So we basically just want some like apply some explainability tools or some interpretable by them, or whether we can interpretable that outputs also that need some like human assistance also for that reviewing their the AI outputs. And actually it's sometimes it's mandatory, or some also build some confidence, some confidence scores, or if we can give like some reasoning, the probability reasoning, etc. Then I think in some cases we can build trust on this AI output.
Thank you. Maybe,
So since the project is more focused towards the financial use case, so we taken a lot of steps to ensure that our response, like our system is generating like actually responses like 99.9% of the time. So one of the things that we are doing is we have a corpus like let's say around 50,000 to 20,000 queries. So we run this automation suite on daily basis to ensure that our models are not actually getting hallucinated and that they're not getting drifted away. So that's one thing, and also we have a lot of people validating their responses on a daily basis. So this is one, and we also have an LLM as judge machine, and with a lot of like breakpoints in between. So these machines will all will be like constructing and then they will be actually like generating they like hiring queries and will be used for validation purposes. So we have a lot of people also in the team. It's not only like it's not only completely automated. We have a lot of human in loop solutions as well. So this is some of the solutions.
It's a mix of human validation, domain expertise validation, and also some systems in place like LLM Judge or other multiple breakpoints to make sure that the system is trustable and gives better output. So next will be one of the primary things which is very important for any industry, right? So productization challenges. So you may have a very wonderful model, but the size is not fitting to your use case. You don't have that much big GPU, or even if you have, the cost doesn't make sense when you are developing a product. So what is the way you deal with that challenge, like production efficient challenges? So there is a model size, then latency and multiple other issues which comes when your product is in some. So how do you deal with that? Maybe you can start with Sudesh. Sudeshna? Am I audible? Okay. So maybe we can start with.
For this step, what we are doing is so one thing that so we are always experimenting with the LLMs that are smaller in size. So one thing I feel like we are already on the safer side because so since we are actually dealing with LLMs, the smaller side and like we want smaller size segment. So taking them to the production and then scaling them is not actually that big of an issue that we are facing right now. On that front, like it shows to go with the smaller LLMs because one thing is like latency is the top priority, and then like smaller is LLM, and we can actually fine tune them, and then like for our use cases, and we can cut down on the latency front. So that's one thing. Yeah, even for the optimization side, like we can actually do a lot of LLM optimizations or any other like platform optimizations that we are choosing to host a model somewhere. So these are all the things that, yeah.
So how do I say whether you should fine tune a model or take a small? Whether you should fine tune for your analysis or something, or you should take a smaller complex solution?
That's an interesting question. So I would say, so we have a list of like data sets, like we have a list of queries and also their labels. So we try to run the base model itself first, and we try to analyze the accuracy and what's the error rate
of that model. So if the accuracy of that model, let's say like 12.53, if it's satisfactory, then we can actually go in with contextual and crucial prompting or like just prompting based approaches. But if it's not like used for like the accuracy is something that we cannot actually take forward. So in that case, we actually go with fine tuning. So we curate the data and then we get that validation for the like the actual experts, and after that we actually like choose to fine tune the data set. So and once we actually hit that accuracy, let's say like 98% on that data set, and then only we'll be taking that to the product and make the models for our customers. Yeah.
Yes. Grant modeling, actually we are doing any qualified tuning locally, so we are using actual or any of our use cases that we have present, like rental models, a short power and random cheats from them, and then building notebooks between our AI models, whether it be like GP models or smaller models. So usually like resource constraints are not that big of a thing, and I thought that because beyond like our data sets more or less look like generating risk statements based on different use cases. Like if it's like an AI use case, then there will be like different attributes and what are the end users on that data system. What is the like severity of data that's going in and going out with the AI system from a risk perspective. And we can generate a risk statement out of that on the about some specific controls which can be used to leverage sort of like control that risk. So our systems are more like chatbots and they are all sort of like posted on Xiaomi cloud ecosystems. And we have like other similar sort of from like Google or the AWS systems, but Platform we are mostly calculating.
I think it's like always a trade-off. Yeah. Actually, it's like always a trade-off between choosing like whether we fine tune or whether we select a smaller model. What is the latency requirement? What is the cost requirement? And what is the resource we have at hand? So it's like there is always a trade-off between that which we need to optimize. So depends on the use case and very specific to understanding what the domain expects for that use case. That's what my understanding was based on all this. So another aspect, like, I'm not sure if you go from RAD. So do you think like RAD works like what are the challenges with that? So have we already reached the pinnacle of information retrieval, or there are still challenges with that in practice in production, which we still see? Maybe we can start.
Yes, so to be honest, like the only application that I'm aware of is for one company using chatbots to nutrition information relevant to some regulation so that we can have faster retrieval of clauses and sections from regulations like this. So like, there are like plenty of regulations and it's not possible for any 0% to go to all of them. They are like really big regulations and the number of regulations is like huge. Certain set of regulations which are for the financial services sectors like there's one NRDA regulation called New York Department of Financial Services. Like this and ISO bodies which are like numerous sites, few applicable cybersecurity, applicable to SOX based companies. So SOX is something that the financial services society often in terms of tax audits and all that. So usually what we are doing is building like chatbots so that It's like faster fewer of process and sections and maybe like a simpler interpretation of the process which are in those regulations, because maximum of these regulations are like legal statements. It's difficult to understand what exactly the requirement is from those statements. Like, say for example, anyone campus would be saying something like this that it is like a cyber security incident happening in your organization, then you should be retaining the audit clause for 5 years if so things happen, or 3 years if certain conditions happen, even like that. I mean, it would be like a list of, I mean, just a single clause would be like a big list of points, like maybe 3 pages. So exactly which clauses are being used. So that is where we are usually building chatbots to retrieve information related to these in a faster way. And I mean, the recent chatbot that we have worked on is using Redis database. So these regulations, like we have like a virtual machine with which we have deployed containers and the Redis database is configured inside which we are like uploading all these regulations. And outside what we are doing is we are using like GPT protocols. It's like some struggle Redis database using some similarity based searching, and then like using our search results along with the users in an appended form for the better contextual response. That's the kind of conflict that we are using chatbots in the organization.
Is the result good enough or you see any challenges?
The results are okay. I would not say that we are like 100% happy with that, because even now, like, we are not really like finding GPT models based on these financial services. These regulations are being like that. I mean, at least my company, like that company is not looking forward to model finding so much at this point. They are more on like building RAG applications. They are good, like they would be like sort of picking out the relevant clauses, but then to some extent human interface is also needed, right? Somebody has to go through the search results and make like do like a control sort of thing in the regression to sort of analyze whether the search results are accurate. We are doing some sanity checking at this point. So everything is in the review stage at this point. Because the results are not very bad, but not very good either. That's
I think there is always a like trade-off between fine-tuning or doing that, and even depends on where you're working on what you think is good for the thing. So for us, RAG has been working really good, but also we did find a few problems with that. So one issue is RAG is something static in nature. So someone or like we need to have a system that's like constantly updating the information to the RAG. So that's something that is a major problem. And the other thing is the problems with so if there's too much content and too much documents in the RAG. So one of the issues that we had to face was the reranking issues. So getting the relevant information, getting the information from the accurate document is something that is one of the challenges. So that's where reranking actually comes into play. But though we actually did some optimizing into the reranking side, so we were facing some issues with that. So it's because a lot of information with the RAG is completely like we are having overlapping information within these documents, and the rehackers actually are getting confused. So this is another challenge that we faced. Yeah, apart from this, the RAG has been working really great for us. We don't have any much issues apart from these two. I will talk about my perspective. I was at Walmart, so it's like Fortune 1 company. It's a huge, huge, a huge number of applications. There nobody does this going fine tuning in general. But what is happening is what I have seen, like there are so many applications which is just running using prompts and at multi-stage. So they are in multi-stage prompting at multiple levels. and it's running just on prompts. So even RAG is not needed. So RAG is also needed only when we have something where we want to extract information from and get some conclusion. But many of the applications, just some good prompts and having it multiple stages is also going to be enough. So I think there are a lot of things which depends on the use case and how the context is. I think is not limited. So maybe I will open it to the audience. Any questions you want to discuss?
I just had a question, sorry, I couldn't think of your name, the gentleman on the far end. Yeah, you were saying that, I was just fascinated, you said you were testing the system daily, to check for hallucination and things like that, so that was interesting to me that you, felt that was necessary, maybe you could explain that a bit more.
Absolutely. That's an interesting question. So we have a preset data set. We have a huge corpus of data set, which actually does nothing but classification jobs. Let's say we are having some ontologies and in that ontology we have like levels of classification, levels of ontology. So for this we have a query and the expanded label. So we have certain data sets. So we actually run this suite on like midnight or like let's say 2 a.m. on a daily basis, and we actually check for hallucinations models. So it's obvious that like we won't be able to like see much differences between like the day one and the day two, but over the time we can actually see from how the model has like hallucinated or drifted from like day one to like let's say day 20 or something. So this is something that was very common with these open source models that we faced.
Maybe I'll ask one follow-up question then. So you mentioned that it's correlation itself. So you mentioned that in RAG you were facing one major problem, which was the knowledge was not getting updated. But I think that is what RAG is used for. Like in case of LLMs, right? We use RAG so that we can get all external knowledge. So I didn't quite catch what was that major problem involved.
I can explain. So let's say you actually are a company and then which follows the clients. And these clients are having their own information or documents. So one way is like these clients can actually send over the documents to us and we actually update them manually. So the other way is like the clients are actually alone more than like send over the documents and keep manually validating it and updating that system is something that's not scalable. So we want to get that process. So we actually let the clients upload their documents automatically onto the system with the human in loop. So why we have to like include a human in loop solution is because like sometimes sometimes the clients are actually like constantly updating their documents and stuff, and then we should actually keep a track of that and then like make sure that our systems are not actually getting hallucinated just because of a client X getting like onboarding new documents and stuff like that. So that is something that was a bit of a, it's not a major issue though. It was something that was actually having some issues with the system.
Basically, uploaded documents are your RAG data that you are building for.
Exactly.
I would like to ask you that RAG is giving an answer, but how is it explained? Means how can I believe everything? Means from the explainability point of view, how it is responsible in every answer one user should believe. What the industry is working from the explainability point of view, because in defense, in medical field, it is most required now.
Oh, that's a good question. So we have tuned our models in a way that so the model only answers from the documents. So if something goes out of the document, if whoever, if a user is asking something out of the document, so our models won't actually answer that. So we either actually close the document itself so that the user can actually go through the documents. So I agree with that. Explainability is something that is very much important, but we haven't thought about that as of yet, I guess.
For explainability, as in Walmart, we are doing something. So we had chatbots. So when we were giving the answers, so even though it was an in-house chatbot, but then the business people wants to know why we are giving some answer. So we gave them the reason behind the answer. So basically, we have this chain of thoughts, right? So that chain will be given in some English language. Like how we came up with the answers. We'll leave that first. That's how we develop confidence. Even if you are doing a like SQL query which you are running on the database, how that query is generated, what is the reason behind it, that chain will give in some form which can be consumed by the user. And then people can validate whether it's right or not based on their knowledge.
Okay, thanks. Let me, then I mean, it's a very high level nature. I mean, may not be answered right away. I mean, this all of you. I mean, see, I mean, you are using this LLM based models which are developed by commercial houses, right? And you also belong as a user. You also belong to commercial houses, right? Now, honestly, I mean, even we from academia are using these LLM-based models as users. So, I mean, in your opinion, I mean, what can academia do in this, ecosystem? Okay, so you as users, I mean, what do you feel where there might be some gap that academia can actually fill?
Very interesting question and very much what is happening right now. So I think that's the I think from my side, what I think is every business has some dependencies. I can't, if I want to run a business, I'll run a show, I think there will be some dependencies. Right now, everyone has dependencies on GPT or the other Gemini or other external models. So in India, we are trying to develop this Sarvam or other people are trying to develop in-house things, in-country things. But then I think there is one more thing that probably for many companies are domain specific, so they don't even need LLMs, they need SLMs. So SLMs are something which is very custom. So like maybe we use some open source architecture and train on that domain and customize that. So now it always depends on the priority. Some companies will have the priority that I want to develop my own system. Some will tell that no, I'm okay to spend and I will outsource. It all depends on the planning and prioritization. But I strongly feel that in India, I mean, this SLMs are going to come very, very good, and academic partnership is very important because what happens in industry, it's cutthroat. I mean, people don't have that much time to. I don't know about some research labs that they're like Microsoft and all, but right now they are also like product specific. So like long-term research which happens in places like OpenAI or other labs, right? So that is really needed for industry, like those kind of partnerships where there is a long-term collaboration thing where the research part is taken care of by the academia in the long run, because that long horizon and spend taking a like industry person and putting them onto that research part, that is difficult. I think from for any company at least, will make size, even big size like Walmart, I think they are just consumers. So they are not trying to develop anything because they don't find any sense for that. But then it makes sense for many companies because they are spending heavily, and for them, if they get something which is in-house, but for that, they don't have that expertise or space to do that. So there, if academia comes, I think which is happening a lot in India, and if these things can be bridged and made much better. where we have very close partnership. Obviously, for research, we definitely need partnership.
I don't know what I think it's the whole AI systems going up. I think there is a very big industry for AIC trustworthy AI. Like, many of our clients say whether it be financial services stuff, like insurance companies or banks or whatever, like many of them have like chatbots or customer support for their internal specific use cases. So what we are feeling is regarding hallucination, AI bias, and toxic content generation. Like if you're having an AI system or like customer facing websites, you wouldn't want your chatbot to generate some toxic content that might address all the users. So this is not just from a customer satisfaction standpoint, but also in terms of compliance with AI-based regulations that are slowly emerging. Like European Union has come up with something called the AI Act. It is to some extent like in drop stage right now, but I think it will be like very much in the coming 1 or 2 years. So I think that academic take part is to develop high quality benchmark data sets to test, like to benchmark AI systems on the basis of bias, hallucination, generating toxic content, and these areas. Like this is something that is related not just for customer satisfaction, for compliance with some of the classes of regulations that are applicable from them. So this is something, this is one point. And another thing which like I think many even the industry are also facing is machine unlearning challenge. Like once you have already trained your LLM based on some data, you might come across some point where you would be thinking that okay, I should have trained my LLM based on certain data samples which maybe contain some PII information. So in those cases, it is not probably computationally, it might get very expensive if you have to like retrain your base model from scratch on the data set. So it might be, I think it is these cases where machine learning comes into the picture. I think it is very much in the mature stage right now, but if we can have more state of the art methodologies to like unlearn some of our or retrain LLMs on some specific data samples which might be like consisting of some PII data or like containing PII information or financial information like that. So this was my information.
What I feel is, so if a person is actually working in a company which its objective is to like build everything from scratch, so that's where the academic experience actually comes into play. So my one friend of mine is actually working in this company, and then so the entire objective of the company is to build everything let's say like some medical use case, and then so they are planning to build everything in our website. So that's where like he happens to come from an academic background, so that's where his expertise is actually like moving over there. So he's able to like have that fine like expertise of academia and the industry, and then be able to like get that thing done in the like the fastest way possible, get articulated, achieving the state of the art results. So that's something that actually felt. So it actually completely revolves around what the company's objective is. So the company's trying to build something, they have time, they have the money and the stuff, like they can put it over there, and then like we can actually acquire the talent who are actually in academia, and also about the industry, because what actually happens is people who are like majorly into academia, like they don't understand the situation more properly in the company. So they try to think about from what the company's objective was, like, oh, okay, so that's something that is very much important. So yeah, so and also like academic expertise, like even a person is completely in industry, like they can actually go about reading papers that can be adopted in their company. Like let's say if the company is focused on prompting, like we can actually go about reading like some prompting state-of-the-art prompting techniques and stuff, and then apply it over that, and then let's see we can get the state-of-the-art data. And so that's my opinion.
So other things which came to my mind is like right now what is happening, the companies have their inbuilt policies on the data security and all. But if you just see like everyone, the common citizens in India or I think across the world, they are just typing in everything on this on GPT or Gemini. So every personal data is actually going there. So I mean there is a huge role which academia has taken. Any other questions? Okay, thank you. Thank you.
Okay, thank you, panelists over here. So we call it a day. Yeah, thank the panelists. And so tomorrow will start 9:30. Okay.
One announcement, those who apply for it, Ireland, please meet me tomorrow or today. Tomorrow before Friday. I think some of them fill the form after a week. So because I forgot to turn up the responses, I got some responses. They will not try them because I already sent the email for trial connections before. Tomorrow we have a photo session after tea. First tea. And for listeners, there is some problem in internet. We are resolving it. So apologize for that. Maybe I will share some new IDs in few minutes or maybe after going questions.
Give the chance to